హలో హలో మ్యామ్ మల్లిప్రియ గారు. హలో మ్యామ్ మీ వాయిస్ రావట్లేదండి, ఒకసారి చెక్ చేయమని.
హలో సార్.
ఓకే మ్యామ్, ఓకే
ఓకే
వస్తున్నాను.
ఓకే సార్.
ఓకే.
హలో హలో సార్, వాయిస్ వినబడుతుంది కదా సార్ రాఘవ్ గారు?
వస్తుంది మ్యామ్, వినిపిస్తుంది మ్యామ్.
ఓకే సార్.
ఓకే మ్యామ్.
హలో హలో
హలో మేడం,
వాయిస్ వినిపిస్తుంది కదండి?
వస్తుంది మ్యామ్.
హలో మ్యామ్. ఓకేనా మ్యామ్?
హలో
హలో
రిమైనింగ్ వాళ్ళు సైలెంట్గా ఉండమని మీరు మాట్లాడేటప్పుడు
ఓకే
కూడా తీసుకుంటాం.
ఓకే
ఓకే.
Nanaji sir, good morning sir. Nanaji sir, good morning sir.
Hello. Hello.
Hello. Good morning sir, Nanaji sir.
Madam, good morning.
Sir.
Okay. మేడం స్టార్ట్ అయిందా ప్రోగ్రాము?
ఇప్పుడు స్టార్ట్ అవుతుంది సార్.
నేను యాక్చువల్ క్లాస్ పెట్టాను, నాకు ఇది ఉందని తెలియదు.
10కి ఇనాగరల్ ఉంది కదా సార్.
10కి ఇనాగరల్ ఉంది. ఓకే ఓకే రైట్ అమ్మా. మాస్టర్ వచ్చారా ఆయన, ప్రొఫెసర్ గారు?
సార్ వెబినార్ లో ఉన్నారండి, ఇప్పుడు జాయిన్ అవుతాను అన్నారు. ఇన్ 10 minutes లో జాయిన్ అవుతానండి.
ఓకే. బెస్ట్ ఆప్షన్ గివెన్ స్పీచెస్ విత్ స్టూడెంట్స్, ఐ థింక్ బెస్ట్ ఆప్షన్. ఓకే.
Yes sir.
ఎవరు? డాక్టర్ కేర్ మేడం.
రమణేశ్వరి మేడం అండి, ప్రిన్సిపల్ సార్, యూనివర్సిటీ కాలేజ్ ఆఫ్ సైన్స్ అండ్ టెక్నాలజీ ప్రిన్సిపల్.
గుడ్ మార్నింగ్ మేడం.
సార్ గుడ్ మార్నింగ్ సార్, వెల్కమ్ సార్.
తర్వాత ఇంకొక మేడం ఎవరండి? డాక్టర్ వి
మల్లి ప్రియ అండి, అవర్ కొలీగ్, మై కొలీగ్ సార్.
Good morning, sir.
అమ్మా గుడ్ మార్నింగ్.
Good morning, Principal Ma'am, Ramneshwari Ma'am.
గుడ్ మార్నింగ్ మల్లి ప్రియ.
Thank you, ma'am.
మేడం మీరు ఏ డిపార్ట్మెంట్ మేడం?
నేను జువాలజీ సార్.
జువాలజీ అండి.
సార్
ఐఎమ్ నానాజీరావు ఫ్రమ్ ఆంధ్ర యూనివర్సిటీ మేడం. స్టూడెంట్స్ ఆల్రెడీ జాయిన్ అయ్యారండి?
జాయిన్ అయ్యారు సార్.
ఓకే ఓకే. వీసీ గారు త్రూ వెబినార్ అయినా ఆయన కూడా త్రూ జూమ్ ద్వారా జాయిన్ అవుతున్నారా?
అవును సార్, జూమ్.
రైట్. మీకు ఇప్పుడు క్లాసెస్ పెట్టారండి మేడం?
ఉన్నాయి సార్.
ఆఫ్లైనా ఆన్లైనా?
బోత్ సార్.
బోత్ అవుతుంది. బోత్ ఆన్లైన్ ఆఫ్లైన్. ఓకే ఓకే.
హలో, నమస్తే సార్. నానాజీ సార్,
సుజాత
నమస్తే సార్.
అక్కడ ఉన్నారా? ఓకే ఓకే.
ఎస్ సార్, 2 years అయ్యింది సార్ ఇక్కడ జాయిన్ అయ్యి. సారీ సార్, మీకు ఇన్ఫార్మ్ చేయలేదు.
అవునా? ఇదిగో మీ ఎవరు రేవతి మేడం గారు చేశారంతా.
ఎస్ సార్, ఎస్ సార్.
మీరు అక్కడ ఉన్నారా?
ఎస్ సార్, హ్యాపీ టు సీ యూ సార్. థ్యాంక్ యూ సో మచ్.
నేను కూడా
కలుస్తాం సార్ ఈ మంత్ ఎండ్. మన సార్ది
మూర్తి గారు వాళ్ళ అమ్మాయి మ్యారేజ్ ఉంది కదా? అవును.
ఎస్ సార్.
ఎక్కడ స్టేయింగ్? ఎక్కడ? అక్కడనా?
యూనివర్సిటీ హాస్టల్ సార్. యూనివర్సిటీ హాస్టల్.
వెరీ గుడ్. బాగుందంతా?
అంతా ఓకే సార్. అందరూ బాగున్నారు సార్ ఇంట్లో?
అందరూ బాగున్నారు.
థ్యాంక్ యూ సార్.
ఓకే ఓకే.
వెల్కమ్ టు ద యూనివర్సిటీ సార్.
థ్యాంక్ యూ వెరీ మచ్. థ్యాంక్ యూ. అక్కడ ఏం టాపిక్ చెప్తున్నారు మీరు?
నేను సార్ లాటిస్ థియరీ సార్ అండ్ గ్రాఫ్ థియరీ సార్.
గ్రాఫ్ థియరీ
సార్ అండ్ డిఎంఎస్ టు. ఎస్ సార్, డిఎంఎస్. ఎస్ సార్.
బాగుంది. పర్లేదు, ఏమన్నా డౌట్స్ ఏమైనా ఉన్నప్పుడు అడగొచ్చు. నో ప్రాబ్లం.
షూర్ సార్. థ్యాంక్ యూ.
ఆల్వేస్ వెల్కమ్.
ఎస్ సార్, థ్యాంక్ యూ సార్.
అంత కంఫర్టబుల్ గానే ఉందా అక్కడ?
ఎస్ సార్, అంతా ఓకే సార్. ఎవ్రీథింగ్ ఈస్ గోయింగ్ గుడ్ సార్. మా ప్రిన్సిపల్ మ్యామ్ రమేశ్వరి మ్యామ్ అండ్ అంతా స్టాఫ్ అంతా చాలా సపోర్టివ్ గా ఉంటారు సార్.
ఓకే ఓకే.
థ్యాంక్ యూ సార్. నేను నెక్స్ట్ మాట్లాడతాను సార్.
Good morning, sir.
Madam, good morning.
Yes, sir. Good morning, sir.
Good morning, Andy.
Sir, good morning, sir. Ramneshwari.
Good morning, Principal Garu, Ramneshwar Garu.
Masharu, good morning. Nanajiro from Andhra University.
Good morning, Nanajiro Garu. How are you?
Sir.
I'm extremely fine. Thanks for joining.
Yes, thank you.
I am happy to see you here.
Thank you.
So.
నేను చక్రధర గారు పిహెచ్డి మాస్టర్, ఫస్ట్ పిహెచ్డి.
వెరీ గుడ్, ఎక్సలెంట్.
చక్రధర గారు మీకు తెలుసు కదా మాస్టర్?
తెలుసు, బాగా తెలుసు. ఐ నో హిమ్.
మాస్టర్ దగ్గర ఫస్ట్ పిహెచ్డి.
హౌ హి ఇస్ డూయింగ్ నౌ?
హి ఇస్ యాక్చువల్లీ ప్రెజెంట్ వర్కింగ్ ఇన్ మాస్టర్ చైతన్య ఐఐటి స్ట్రీమ్ లో.
మేడం అక్కడ వర్క్ చేస్తున్నారు?
మేడం సెయింట్ జోసెఫ్ కి వెళ్తున్నారు మాస్టర్.
వెళ్తున్నారా?
వెళ్తున్నారు కదా, రిటైర్డ్ యాక్చువల్లీ.
రిటైర్డ్. లాస్ట్ టైం ఐ మెట్ హర్ సెయింట్ జోసెఫ్ కి ఏదో ఇన్స్పెక్షన్ కి వెళ్తే.
Sir.
Convey my regards to both of them.
Sure, Masher. Sure. Thank you.
Okay, thank you.
Revati madam,
Yes, sir.
please start the program.
Yes, madam. Okay, madam. Malipriya madam, please start the program.
Okay, ma'am. Good morning, all. Esteemed Vice Chancellor, Professor M. Jagannath Rao Garu, respected Registrar, Professor B. Gangarao Garu, respected Principal of University College of Science and Technology, Dr. K. Ramneshwar Garu, course coordinator of Department of Mathematics and convener of today's webinar, Dr. K. Revati Garu. Today's webinar resource persons, Professor K. Keshav Reddy Garu from JNTU Anantapur, Dr. G. Nanaji Garu, Associate Professor, Andhra University, all the principals of university colleges, deans, EC members, teaching staff, research scholars and students. Myself, Dr. V. Malipriya, Assistant Professor, Department of Mathematics, welcome you all for the National Webinar on Recent Advances in Mathematical Sciences on the eve of 133rd birth anniversary of Sri Srinivasa Ramanujan, an Indian mathematician who made extraordinary contributions to mathematical analysis, number theory, infinite series, and continued fractions. From the Department of Mathematics, I wish you all happy National Mathematics Day. To introduce about the university, Adhika Nana University was established on April 2006. This university aims to combine the pristine cultural and the contemporary demands of educational excellence in its vision. The university consists of 4 colleges in main campus, namely University College of Arts and Commerce, University College of Engineering, University College of Education, and University College of Science and Technology. The Adhika Nana University is having extension campuses at Kakinada and Tadepalligudem. As far as the number of affiliated colleges are concerned, this university stands tall, being the largest in the state of Andhra Pradesh, affiliating nearly 450 colleges. To introduce about the Department of Mathematics, the Department of Mathematics was established in 2007, offered 5 years integrated mathematics and computing course till 2014. In 2014, 2 years MSc Mathematics course has been introduced. From the academic year 2016-17, MSc Applied Mathematics was introduced. For both mathematics and applied mathematics courses, the intake of the students is 45. The Department of Mathematics having faculty members with specialization in pure and applied mathematics. The department is having a strong group of faculty members working in various areas of algebra, operation research, number theory, analysis, fluid dynamics, topological dynamical systems, etc. Coming to today's webinar, we are very fortunate to have eminent resource persons. I hope all the participants will make use of this webinar and make it a grand success. Thank you all. Now I request convener today's webinar, convener Dr. K. Revati ma'am to give her opening remarks. Over to Revati ma'am.
Thank you, Dr. Malipriya madam.
Okay, ma'am.
Good morning to Honorable Vice Chancellor, Professor M. Jagannath Rao Garu, respected Registrar Sir, Professor B. Ganga Rao Garu, respected Principal Madam Dr. K. Ramneshwari Madam, University College of Science and Technology, Professor Teki Sir, University College of Arts and Commerce, EC members, Dr. Jagan Mohan Reddy Sir, Professor Ramesh Sir, Professor Ashok Sir, distinguished guests, Professor E. Keshav Reddy Sir, JNTU Anantapur, and President of Andhra Pradesh and Telangana State Mathematical Society, Dr. G. Nanaji Garu, Head of the Department, Andhra University, and senior faculty, research scholars, students, colleagues from the university, several participants from different organizations. Once again, good morning to all. Myself, Dr. K. Revati, Assistant Professor, Course Coordinator, Department of Mathematics, Adhika Nana University, and convener of this webinar. Today, we are conducting a national webinar on recent advances in mathematical sciences on the occasion of National Mathematics Day, in the remembrance of the great, prominent, and well-known Indian mathematician Srinivasa Iyengar Ramanujan. In 2012, former Prime Minister Manmohan Singh declared December 22nd as National Mathematics Day. All of you know that mathematics is the queen of sciences. Mathematics is very useful in our day-to-day life. It can help us do many things that are important in our everyday lives, such as in banking sector for managing money, shopping for best price, figuring out distance, time, and cost for travel, etc. All are learned in operation research. Mathematics has vast real-life applications, such as algebra, computer science, cryptology, differential and computational geometry, probability and statistics, operation research and optimization, and so many. Along with these, mathematics plays a major role in some other fields. Today, our prominent speakers, Professor E. Keshav Reddy Garu and Dr. G. Nanaji Rao Garu, will deliver two advances in mathematics: differential geometry for machine learning and quasi-complemented almost distributive lattices with their talks. Differential geometry is a mathematical discipline that uses the techniques of differential calculus, integral calculus, linear algebra, and multilinear algebra to study problems in geometry. And lattice is an abstract structure studied in the mathematical subdisciplines of order theory and abstract algebra. One of the most important practical applications and also one of the oldest applications of modern algebra, especially lattice theory, is the use of Boolean algebras in modeling and simplifying switching or relay circuits. For this webinar, 178 members are registered. Welcome to all the participants who have enrolled this webinar and appreciate your zeal and interest to learn new topics in mathematics, and hope today's talks will lift your knowledge to new levels of understanding in mathematics. Thank you, one and all. Now I request Dr. L. Sujata, one of my colleagues, to introduce our chief guest. Over to Sujata, madam.
Sir, namaste, sir. VC, sir. Namaste, sir. Namaste, one and all. I am Dr. Sujata. I'm very happy to introduce our esteemed Vice Chancellor, sir, Professor Mokka Jagannath Rao Garu. Professor Mokka Jagannath Rao Garu, Honorable Vice Chancellor of Adikavi Nannaya University, Rajamahendravaram, has done his education both in India and abroad. He got his master's degree in engineering from University of Alaska, USA. He got his PhD from Andhra University, Visakhapatnam in the year 1985. He joined as assistant professor in the Department of Geology, Andhra University in 1986 and later promoted to professor and head of the department from the same department. He is a serious researcher and academician having more than 33 years of experience in both teaching and research. He has published nearly 150 papers in national and international journals. 33 scholars got awarded PhD under his guidance. His students are not only from geology but also from computer science, geoengineering, geophysics, and allied physics. He has strong research collaboration with various organizations from USA, Canada, and Australia, and many more. He has completed 8 funded projects from leading funding agencies of this country, including DST, UGC, CSR, DOD, APMDC, DMRTUF, MOES, ISRO, and ONGC. He got his consultancy projects from ONGC, namely studies on volcano evolution of Mahanadi Delta, studies on land subsidence due to hydrocarbon exploration and exploitation of KGPG Basin, AP using remote sensing and field studies. He has a vast experience in administration. He held various administrative positions like Director for Information Management Center, Andhra University, Dean for PG and Professional Examinations, Andhra University, Director for International Students Affairs, Andhra University, Director for Delta Studies Institute, Andhra University, Chairman for Board of Studies, Department of Geoscience, Ambedkar University, Srikakulam, Head of the Department, Department of Geology, Andhra University, and many others. He has filed a patent entitled An Inventive Model that explains the genesis of Bay of Bengal and Arabian Sea, which is under consideration. He got many awards and honors, including Dr. Sarvepalli Radhakrishna Award, the Best Academician Award of the Year 2019 by Andhra University. Awarded Scientist of the Year 2017 by National Environmental Science Academy, New Delhi. He was in editorial board of Indian Journal of Environment and Eco-Planning. He is the member of various professional scientific bodies of national and international repute. He is the NAC assessor and many more. He is a member in various board of selections committees at national and state level. His earlier selections include UPSC, Civil Service, Group B Service, UPSC exam in 1985, UPSC Geologist Examination All India 11th rank in 1983. Because of his passion for teaching, he is in teaching field, teaching life. His vision is to see that our Adikavi Nannaya University should be the international institute of choice for education, research, training, and consultancy. Thank you, sir. Thank you for giving this opportunity. Thank you, sir. Over to Ravati ma'am.
Dr. Ravati, you unmute. Again, you have to unmute, yes.
Good morning, sir.
Morning.
Now, VC sir will address the gathering, sir.
Okay, thank you, Dr. Sujata, for your nice introduction. And I'm very happy to see my friend and colleague, Dr. G. Nanaji Rao Garu, Department of Mathematics, HOD of Andhra University. Andhra University known for the great mathematicians, including his guide, who is my friend and my colleague at Andhra University. And similarly, we have Professor Kesava Reddy Garu he is also here to deliver the expert lectures. And on this occasion, on the National Mathematics Day, today we are celebrating the birth anniversary of India's great mathematician, Srinivasa Iyengar Ramanujan. And in this connection, I congratulate the Department of Mathematics for organizing this webinar on recent advances in mathematical sciences. I'm happy to see all these principals here. Principal of Science and Technology, Dr. Ramaneshwari. Principal Arts, Commerce and Management, Professor Teki. Principal College of Education, Professor Subbarao. And EC members, Professor Ramesh, Professor Ashok, and Dr. Jagan Mohan Reddy. And all the participants and student delegates, student participants, and the convener of this webinar, Dr. Ravati and her colleagues at the Department of Mathematics. I'm extremely happy and extend my greetings on this day of mathematics, National Mathematics Day. And good morning to all of you, ladies and gentlemen. When I see this subject, recent advances in mathematics and mathematical sciences, mathematics is I feel it is the subject which is relevant. It's like a god to the science and technology and engineering and social sciences. I strongly feel there is no subject where mathematics cannot be applied. So each and every subject, whether it is physical sciences or engineering or earth science or life sciences or social sciences, management, any subject you take, mathematics is having a lot of applications. I strongly feel if you theorize something, if you model something, if you apply and create some innovation, you need to test those innovations, those theories with a mathematical background, then only it is justified. I always feel we all, the scientists, whether we are from physical science or life sciences, we need to utilize the mathematics in our research. Without having the mathematics as a part of the modeling or the hypothesis development or analysis, especially when you're dealing with the dynamic processes. Like suppose a geologist, we wanted to study the coastal process, where these coastal processes affect the coastal erosion, coastal deposition. When you study and present the descriptive way, it may not give the realistic picture unless you use the mathematical principles and the erosion and deposition is occurring in a given area. So mathematics is the tool. We need to use these experts. We need to go with our research and subject and take their help in getting and modeling and theorizing our observations and our data. So that is where we are unable to do that. So we need to do the interdisciplinary research. When you're coming to this National Mathematics Day, we are so fortunate that India is blessed with a number of world-class mathematicians. India is the country where the mathematics is born, actually, in fact. So this is the country, right from the history, you can see in the history, we are the greatest mathematicians. One of them, who is now we need to remember today, is the Srinivas Iyengar Ramanujan. When I was in US, while doing my master's, I have taken a course in applied statistics. When I found that this subject, I have some problems and I need to meet my professor to clarify my doubts, I went to the American professor. When he's seen me, he asked one thing: "Are you from India?" Yes, I said yes. "Have you seen this guy?" And he has shown me that picture on his cupboard. That is he's the Srinivas Iyengar Ramanujan. I said yes, he's a Srinivas Ramanujan. "Have you visited his place?" He said. "Are you from which part of the India?" I said, "I am from South India." "I think you must have visited his place of birth. He's the greatest personality and world-class mathematician." In fact, I lied to him. I never visited his place, but I said I visited his place because I don't want to put myself in a fix at that point of time. He was so happy and said, "It is my lifetime ambition to visit India, visit his place. Even just visiting his place is enough for me." That is the greatness of this person, these mathematicians. Among all these world-class mathematicians of the various different countries. So in this way, we are so lucky, we are so fortunate to know about Srinivas Ramanujan. And though he lived a very short time, at the young age of 32 years, he passed away. Means it's not only loss, great loss to our country, but a great loss to the very mathematicians and very mathematical fraternity itself. So we need to remember, we need to inspire from his works. We need to continue his legacy of doing good work in mathematics. Today's topics in the differential geometry or the lattice theory, these two subjects, even I strongly feel that differential geometry or the lattice theory. When I have seen yesterday, just I want to know what is this and how it can be applied to geology. Then for my surprise, there are a number of publications where differential geometry has been applied in geology, where there are structural deformation, folds, faults, and various geographic and geometric features at micro and mini to mega level and major level of structural evolution. So they have some of the mathematicians and geologists together have done great work on differential geometry towards geological applications. So in this way, we have a lot of applications. When you see this mathematics, you need to utilize them. And when you take up mathematics as an interdisciplinary research, you need to work with the mathematicians, apply in your field of research, and definitely you will come up with surprising and innovative results. we need to work with the mathematicians, whether you are from physical sciences or engineering sciences or life sciences. We need to work with these mathematicians and see how the mathematics can be used in your chosen field of specialization. I once again congratulate and extend my greetings on this National Mathematics Day. And let us all remember the greatest mathematician, Srinivasa Ramanujan Iyengar, and let us inspire ourselves and do good work, not only in mathematics, but using mathematics in our own fields. Thank you very much. Thank you.
Thank you, sir. Thank you very much for your valuable words about Srinivasa Iyengar Ramanujan and the applications of differential geometry in geology. Thank you, sir. And thank you very much for your great support for organizing this webinar.
Masha,
Well-
one point, just one point. Sir, Jaganathan sir, this is sir. It's mute, huh? It's in mute. Okay. Continue, Revati madam, continue.
Welcome, sir. Keshav Reddy, sir. Good morning, sir.
Good morning, ma. Good morning. Yeah.
Our Vice Chancellor, sir, Professor M. Jagannath Rao garu.
Ma'am.
నానాజీ సార్ మీరు ఏదో చెప్తున్నారు వీసీ గారికి
sir.
చెప్పండి.
Sir, Jaganathan sir, VC sir.
Sir.
There is one more importance of our Department of Mathematics already, you know.
Yes.
Professor Meenakshi Sundaram.
Yes.
Meenakshi Sundaram.
Yeah.
He is a contemporary and together research with Albert Einstein.
Oh, excellent.
That is another great thing of our department. He is the first head of the Department of Mathematics, sir. Professor Meenakshi Sundaram.
Yes.
And both Einstein and Meenakshi Sundaram together, they done research in USA together, side by side rooms. Albert Einstein. Yeah.
Excellent.
That is the great of our department.
So we have the greatest people associated with our university, including
yes, sir.
like C.V. Raman.
Yeah, C.V. Raman.
So the greatest Professor Radhakrishnan, and
yes, sir.
So this is all the greatness of the country, because we are becoming like close to 100 years mark now. The Andhra University is completing 100 years very soon.
Yes.
So
Another one, Suri Bhagavantam, you know. Suri
Bhagavantam. Yes.
Prime Minister Scientific Advisor at those days.
Yeah, Swami Jnanananda.
Yes, sir.
All these fellows.
Okay, Masha.
Okay.
Thank you.
Thank you. Nice of you.
Now, Miss K. Geeta Lakshmi, one of our
Assistant Professor, Department of Mathematics, Markananda University. It's my privilege to introduce about great Raman. It's my privilege to introduce about great Indian mathematician Srinivasa Iyengar Ramanujan, a genius who loved numbers, was born on 22nd December 1887 in Idur, Tamil Nadu. Srinivasa Ramanujan, one of the greatest mathematicians of all times, made extraordinary contributions to mathematical analysis and numbers. He was in such poverty that he often sustained on minimal foods and did not even have enough money to obtain paper for his studies. As a result, he used slates for his mathematics and cleaned them with his elbow, leaving to brushes and marks. Even with little formal training in mathematics, he was published his first paper in Journal of Indian Mathematical Society in 1911. Srinivasa Ramanujan is remembered for his unique mathematical brilliance, which he had largely developed by himself. He made great and original contributions to many mathematical fields, including complex analysis, number theory, infinite series, and continued fractions. He was discovered by G.H. Hardy and J.E. Littlewood, two world-class mathematicians at Cambridge, and enjoyed an extremely fruitful period of collaboration with them from 1914 to
1914 to 1918. After his advances, especially in the field of partition of numbers and publication of his papers in several English as well as European journals, he was elected to the Royal Society of London in 1918. Unfortunately, his mathematical career was curtailed by health problems. He returned to India and died when he was only 32 years old. Since his death, Ramanujan's writings have been studied extensively. Some of his conjectures and assertions have led to the creation of new field of study. Some of his formulas are believed to be true, but as yet unproven. Government of India has declared that Ramanujan's birthday should be celebrated every year as National Mathematics Day, and the year 2012 is observed as National Mathematical Year. His contributions in the field of national mathematics has been immense and will be remembered forever. Thank you for giving me this opportunity. Thank you. Over to Rafi now.
Thank you, Geeta. Now I welcome Professor E. Keshav Reddy, sir. Speaker, Professor E. Keshav Reddy, sir. Over to Ashok, sir.
Thank you, madam. Thank you, Rafi, madam. Good morning to Honorable Vice Chancellor, Professor Mokka Jagannath Rao Garu, to the experts, panel members, and participants. I am G. Ashok, working as Assistant Professor in Department of Mathematics. It's my privilege to introduce Professor E. Keshav Reddy Garu, who is an enthusiastic mathematician with ideologistic brain in all the fields of engineering and mathematics. He completed his BSc Honors Mathematics and MSc Mathematics from Banaras Hindu University, and also PhD from Banaras Hindu University on functional analysis. About his professional career, he started his career as a lecturer of mathematics and now working as a professor of mathematics JNTUA College of Engineering Anandpur after crossing different hurdles in life. He published more than 90 papers in both reputed national and international journals. And also he published more than 10 books on his credit covering various research areas and academic curriculum. He has delivered more than 50 plus technical talks in various areas on various platforms to cater the needs of the faculty and students. He is also guiding research scholars by considering new challenges in mathematics. He is a member in 13 professional bodies, which include IEEE, member of 10 plus editorial boards of referred research journals. He is also governing body member of 6 plus premier institutes in India. Coming to the research and consultancy, under his guidance, 12 members have successfully completed their PhD MPhil, 6 members as co-guide, and 3 members working presently. He worked on projects like TCS ION confidential work, research and development of IoT device, Century Landry India Private Limited, Bangalore, finite element method analysis for motorcycle seat cushions, Ticket Plant Solution Private Limited, Bangalore, artificial intelligence project for Wipro, Bangalore, etc. He is a consultant for SVM IT Solutions Ltd, Tirupati, HR Silicon Solutions, Mahbub Nagar, etc. He received National Integration Award of Andhra Pradesh and Telangana State sponsored by Healthcare International. The ISTE Award of Andhra Pradesh and Telangana State Best Engineering Teachers led Sri Jasti Sri Krishnamurti Garu Award sponsored by VNR Vigyan Jyoti Institute of Engineering and Technology, Hyderabad. Award of Distinguished Scientist for the contribution and achievement in the field of functional analysis and optimization techniques, National Award of Excellence, and also received Andhra Pradesh State Best Teacher Award for the year 2017 on 5th September. He has 5,695 citations with 33 H&X score. Professor E. Keshav Reddy Garu has his own modular object-oriented dynamic learning environment Moodle, a site through which he teaches mathematics to BTech and MTech students online. With this, it's a great honor for me to introduce Professor E. Kesareddy Garu, who is a great mathematician and researcher in the field of mathematics in the national webinar on this occasion. Now I request to Professor E. Kesareddy Garu to deliver his talk.
Thank you.
Thank you, sir.
Thank you, Mr. Ashok, for introducing me nicely. Thank you very much. First of all, I want to say I'm not great mathematicians. When we see a Ramanujam sir and like that, we are nil, nothing we are doing. That was the thing what they have done. And those who are listening, I want to speak the youth, young mathematicians. If you see the history, Galileo dies at 21. Galileo dies at 21. If you see Abel dies at 27. Ramanujam sir has died in 33. And Riemann died at 40. So young mathematicians, what is my message I want to give to the those who are in a mathematics field? The mathematics belong to young people. There is no doubt that mathematics belong to a young people. So all the young mathematicians should work hard and make it like this. Once again, I'm speaking the data. If you see the Galileo dies at 21. Abel dies at 27. Ramanujam sir has died at 33. Riemann is 40. What does it mean? I'm not going to say that the old peoples are not mathematicians. Yes, they are, but there should be an innovative type of thing. There should be an innovative type of thing. Then only we can become a success mathematician. In this occasion, I want to speak something, that is, India celebrates the National Mathematics Day today to commemorate the birth anniversary of Srinivasa Ramanujam sir. And Ramanujam sir is remembered for his contribution to mathematical analysis, infinite series, continued fractions, number theory. He also discovered his own theorem and compiled as many as 3,900 results independently. In his short life, Ramanujam sir had a wealth of ideas that have transferred and reshaped 20th century mathematics. And these ideas continue to shape mathematics of the 21st century also. At the age of 31, Ramanujam sir was one of the youngest members of Britain's Royal Society and first Indian to be elected as a fellow for Trinity College, that is Cambridge University. And one thing, what Ramanujam sir was at that time, what was his thought? That when we have an equation, for example, we now what we say, we are mathematician, we are solving the equation. But what was his thought? An equation means nothing to me unless it expresses a thought of God. The equation should express a thought of God. It means something natural or real type of application should be involved in that one. Therefore, after 133 years also, some equation, some part of the Ramanujam sir is unsolved. No one is able to solve that one till now. So that was the reason.
2 minutes కనెక్ట్ అవుతానన్నారు. నెట్ ప్రాబ్లం వచ్చి 2 minutes కనెక్ట్ అవుతాను.
Yeah, there was slight disturbance was there. Okay, fine. So what I'm going to say, this is an era of youth. So youth has to work on mathematics. That was the one thing what I want to say to the youth or younger mathematicians, those who are working. Now, I will go for my screen sharing. Yeah. It is visible?
Yes, sir. Visible, sir. Visible.
Okay. Okay. So I have chosen today's talk as a differential geometry for machine learning. So why I have chosen this one? Because a number of people are working on all the areas. But the thing is, when I say that we are going to work on the mathematics, the mathematics thing is, it's the what is the main thing we are going to say that if I am going to say we are going to work on mathematics, but the thing is now these days the pen and paper mathematics is not going to work. So we should have something real type of application to engineering, society, and so on. So for that purpose, we say the mathematics should be useful. So now the recent thing, what I request the students and the faculty to work on the differential geometry for the machine, because it's a very beautiful area, this one. The very less input is very common and very, what you say, very basic knowledge is needed, and we can apply for the machine learning. So now these days, the mathematics, as I told you, Ramanujan sir has changed the era from 20th century and 21st century, and he has given on a number theory, and now the number theory is having a cryptography application, lot of things. You can have one degree course on the number theory to make it useful in engineering or some machine learning or artificial intelligence or data science. So that was the importance now. So we should also work on the mathematics which is applicable to application part, that is which is applicable to engineering part, real life, and for the society. So that mathematics is needed now onward days. So the thing is differential geometry, curvature of the curve, curvature of surface, application of curvature. So these are the things what we are going to see in this one. Parameterization of a curve. So arc length. So what is the when I say if you see this one, curvature of a curve, when we say curvature of a curve, what does it mean? We have a curvature, and curvature of surface. So what we say, if you take a first piece of paper and bend it gently, it bends it only one direction at a time. At any time on the paper, you can find at least one direction through which there is a straight line on the surface. there is a straight, very beautiful part. What is that? At any point on the paper, you can find at least one direction through which there is a straight line on the surface. So you can bend it into a cylinder or into a cone, but you never bend it without crumbling or distorting to the get a portion of the surface of a sphere. So that is the beauty, this curvature. So we will see this one first, curvature of a curve, curvature of a surface, application of curvature in this one, parameterization of a curve. So when we say parameterization of a curve, so curve, suppose this is the curve, this is a S length, curve length is there, this one, okay, S arc length. So if this arc length I want to write, see this diagram. So AS can be written as XS and YS, okay. So when we say this as XS and YS, so this is the curve length like this, and this is XY direction, and this is AS. You see, this is the curve, and this is the thing what we are going to read now. See the beauty of this one. I will show you the another one. Tangent of a curve. When I say tangent of a curve, what? So this is the curve, this is the curve, this is AS. Now see what is the tangent of a curve. This part, this is a tangent to the curve. What is that one? If you differentiate A, means you are going to differentiate with respect to X and Y, you are going to get a tangent. So A dash S dot delta X. What is delta S? A small part of the curve. So AS plus delta S, AS. So this is the part what we are going to get it, the tangent of a curve. And curvature of a curve, if you double differentiate, if you go for double differentiate, this is the double differentiation, okay? This is curvature. This part we are going to say curvature. It means the parameterization of a curve is a very important point, basic part of any when we go in the differential geometry part. So curve, yes, arc length is this one, and this is AS, and this is XS and YS direction. So this part. Now with this thing, we are going to say tangent. So once we have discussed this one, this is the tangent part. And then we are going to say curvature. So if you double differentiate this A, we are going to say curvature, and this mod is mod of double dash A double dash S is known as magnitude of the curvature. Okay. Now, if suppose, now see curvature, if this part, this I told tangent, this C A dash S plus delta S, this part, this is curvature. A dash S is this one, A dash S plus delta S. When you say A double dash S dot delta S, this is curvature. See the beauty. It means any mathematics part, till now we are working on pen and paper to get it the answer and to get it the correct answer, and what is happening we are not bothering. But if you see what is happening graphically, if you see physically what is happening, you see the beauty of this one. So this is the curvature. A double dash delta S is a curvature for that one. Okay. Now, for example, if you say circle, so what is arc length is? S is arc theta. Is this arc length you are going to say radius, R is the radius, and this is the theta angle. So S is R into theta. What are the coordinates we are going to face? We are going to say X coordinates is R cos theta, and Y coordinates is R sin theta, and AS is XS YS. So this is the coordinate for the any polar circle or any circle which we are going for a polar coordinates. The tangent for this one is, this is the tangent. You see, this is the tangent. A dash X is minus sine S by R, because one differentiation is needed. If you differentiate these two, you will get this two. So this is the tangent. In this, which direction? In this direction, you are going to say. Now this is a directional. Now curvature. So when we say A double dash X, so this is 1 by R is a curvature. This is the curvature. So these three plays a very important role when we say it is a differential geometry. And the normal direction towards the empty side. What is this one? What is this A double dash curvature? Normal direction towards the empty side. Normal direction towards the empty side. Normal direction towards the empty side. Okay. So this one. Now see, this is the normal direction towards the empty side. If you draw a diagram for in every mathematics, what is you say physical interpretation, or you say a diagram when you draw for a mathematical part, then you see have a clear picture. So the normal direction towards the empty side. What is A double dash? Ks ns. What is Ks? Curvature. Okay, n is normal to that one. So this is the normal part of this one. Okay, this is the part of this one, and this a dash s is 1, a double dash is 0. It means when you have a curvature and tangent product, you will get a 0. It means what? Both are orthogonal to each other. Okay, so this type of thing we are going to take it what you say view from that one, and corner model and its signature. When we say the corner model and its signature, you see this is a model. For example, S is 0, this is A to B, this is corner model, A to B, C to D. Okay, now I want to go for this one in this like this. If you see the graph of this one, this A to B, this is A to B like this, and then C to D is like this, and rest of the thing is the rest of the part. This is arc. If you distort this one, A to B is you are getting like this, C to D is like this, and again A, if is loop closed, then A is again going to meet A. So this is the part. And if you say A, B, C, D is like this, if you make not like this, this one, then what is that? A is like this, this portion is A, this portion is B, this portion is D, this portion is D. So like this you are going to make it. And if S is 0 with this one, this is a straight line. You see the graph is a straight line here. If it is a square type or rectangle type, you see like this. If it is something like this, you see this is arc length is like this. So this is the shapes, corner models, and this is known as signatures and the corner models. So Gaussian filter, so what is the curvature means? First of all, if we want to see this one, we have to come from the isometry. What is that isometry? An isometry is a distance preserving transformation between metric space, usually assumed to be bijective. Area preserving is there, geodesic preserving is there, which preserves the geodesic. What is geodesic? Angle preserving is there. Okay, and Gaussian curvature is there. So Gaussian filter and scale space, you see like this. This is plus, this is the part, and this is the part. From this to this we have transformed. It is transformed. And this is the graph for this one. It means A, just now I have shown you, if A is like this is the graph for that one. Okay, now see this one, this two. The same thing, this one, you can put it like this. You can put it like this. It means this plus this, the outcome is this one. This plus this one, the outcome is this one. If you see these two, the outcome is this one. It means when we say the Gaussian curvature type, Gaussian filter, Gaussian curvature, what is that? Is an intrinsic measure of curvature depending only on distance that are measured on the surface. Okay, that are measured on the surface. That is Gaussian curvature is there. And when we say planar curves, a planar curve is one that lies in a plane. Some examples are to be base of a cone. The planar curve must be closed. In the plane, a closed curve is a curve with no endpoints and which completely enclose an area. These are the things what we are going to see for this one. Curvature, scale, and space descriptor. Suppose, see the shape here. See this one, what is happening? This shape I want to preserve. This is a fish. So this curvature, scale, space descriptor, and I want to preserve this one. So this is the preserving part, and this is going to automatically adjust. And this is the graph for this one. This is the graph for this one. This I want to make it, what you say in the engineering part, image processing or image parallel processing, image processing, SVU decomposition. So this is the part. So this is a fish. This is this one. And when it is going to be make it distortion like this, the graph is going to be developed like this. You see this part. So curvature scale space descriptor, it is known as, and this all depends on the transformation. For example, all of you know that the linear transformation, a linear transformation is a function from one vector space to another that respects the underlying structure of each vector space. A linear transformation is also known as a linear operator or a map. Okay, so this is the thing what we are going to see. So curvature of surface. What is the curvature of surface? What do you mean by the curvature of surface? If you take a plate, a flat piece of paper, I already told you, and bend it gently, it bends in only one direction at a time. At any point on the paper, you can find at least one direction through which there is a straight line on the surface. You can bend it into a cylinder or into a cone, but you can never bend it without crumbling or distorting to get a portion of the surface on a sphere. If you take the skin of a sphere, it cannot be flattened out into the plane without distortion or crumbling. This phenomena is familiar from orange peels or apple peels. If you see the orange peels and apple peels, you can try at home. You can take it orange peels or apple peels. Not even a small area of the skin of a sphere can be flattened out without some distortion. Although the distortion is very small for a small piece of the sphere. That's why rectangular maps of small areas of the earth work pretty well. But maps of larger area are forced to have considerable distortion. Okay, the physical description, when we say Gauss filter, we talked about the Gaussian filter. Gaussian filter used in image filtering. A Gaussian filter is a linear filter. It's usually used to blur the image. Usually used to blur the image or to reduce noise. To blur the image or to reduce the noise. The Gaussian filter alone will blur edges and reduce contrasts. Though, for example, Gaussian filter means this one, Gaussian filter. This Gaussian filter makes this all things for the image. Okay, so curvature of surface. This is a point. One by one, you please watch on the screen. So curvature of a surface. Now, normal section. So when I say this, okay, now see, this is the shape. The normal section is going to be happen. The normal section is this one, okay, on the surface. This is the part, and non-normal section means this one. There is a something which is through angle is bent. See the difference between these two. This is non-normal section. This is normal section. So curvature of a surface gives the importance of this one. Now you see, I will make it, yeah. See this one. Normal section means E1 and E2 having theta here. This is the normal section. When you say non-normal section, you see this one. This portion, this is from normal. There is some angle which is not going to be having. So principal curvature. What is principal curvature? Principal curvature plane in all directions. Suppose this one plane in all directions. So what is that? K1 equals to K2 is 0. When you say curvature is 0, this is plane in all direction. Okay. So what do you mean by the curvature actually? So curvature is a measure of how much the curve deviates. Curvature is a measure of how much the curve deviates from a straight line. In other words, the curvature of a curve at a point is a measure of how much the change in a curve at a point is changing. Meaning the curvature is the magnitude of second derivative of the curve at any given point. Okay, this is the thing what we are going to see. So this is all directions. This is a sphere. When you say sphere, what is that? Both equal but less than 0. When you say cylinder, K1 is less than 0, K2 is 0. When you say ellipsoid, both less than 0. When you say hyperboloid, so one is less than 0, one is greater than 0. So this is the principal curvature we are going to see is Gaussian curvature and mean curvature. So when we say Gaussian curvature, it is a concatenation, that is multiplication of K1 and K2 or K1 plus K2. So mean curvature is K1 plus K2 by 2. When we say Gaussian curvature, K1 into K2, and we say that is K. And when we say mean curvature, it is K1 plus K2 by 2. For example, if you see the plane, here K1 is 0, K2 is 0. When you say K is 0, H is 0, in this case, the mean curvature is less than 0. And the mean curvature, Gaussian curvature is greater than 0, and the mean curvature H is less than 0. When you say in this case, the mean curvature, Gaussian curvature is 0, and the mean curvature is less than 0. When you say in this case, ellipsoid, the mean Gaussian curvature is greater than 0, and the mean curvature is less than 0. When you say in this case, that is hyperboloid type, the Gaussian curvature is less than 0, and about the mean curvature we doesn't know. That is, we have to see what will be. It changes from case to case in this case. Okay, parabolic point, suppose, when we say the parabolic point, so K is 0 for the parabolic point. You can see the diagram on the screen. So parabolic point, this is K greater than 0, elliptic point. Parabolic point, elliptic point. See, these two are the things. Okay, and hyperbolic point, K is less than 0. So this F. Klein used the parabolic curves for peculiar investigation to test his hypothesis that the beauty of a face was based on certain mathematical relation. That's why nowadays this is also going to use for the image processing. He has also the parabolic curves marked out on the Apollo Belvedere. So, but the curves did not possess a particular simpler form. Okay, not following the general law. So then they gone for the different type of thing. For example, this is the map given here. Now see here. So like this. So this plane is here, K0 and H0 for this one. This is the plane. This is the cylindrical. When you say this one, K greater than 0, H greater than 0. When you say this one, so these are the parts for different K and H for this map. Okay, and other feature points and edges is, so edges, maxima of curvatures, zero crossing of Gaussian mean curvature, right, ridges and valley for the valleys for this one. Umbilic point, principal curvature are the same. So umbilic point means at that point the principal curvatures are same. So these are the feature points that we have, what we are going to see in this type of things. Okay, and this is a very what you say, very basic type of things or basic type of mathematics which we are going to see in the differential geometry. Lines of curvature. So see here, now when we say the lines of curvature, the principal direction comes in picture. So now the maximum and minimal normal curvature, you see this one, principal directions, there is a direction, principal direction, maximum and minimal normal curvature. Curves along principal directions, PD means principal direction. Curves along principal directions give this shape. This is minimum, this is maximum. So these are the things you see how we can have it as shapes for the line of curvatures. You see this one, bottle, these two bottles, similarity of these two bottles. This is like this and this is like this, if you watch carefully. And if you see these two mugs, see the similarity in these two, see the hand of this one and this one. Okay, so lines of curvatures are very important when we are going to see this type of thing. So curvature primal sketches along lines of curvatures. So a long line of, for example, this is a face mask for some face. Suppose this is a face mask. Now you see here, this is the face mask. Now a long line of curvature. Curvatural primal sketches along the lines of curvature. So if you go along the lines of curvatures, we can have a shape, whatever we want, that we are going to put it in our own mode, our own conditions. What are the formulas in which is involved in this one? For example, surface. Surface means we have a three-dimensional x, y, z, suppose. So x, y, and z is in x, y. This is UV direction like this. This one. Surface normal is given by this one, n, that is x cross x, both the cross product, and modulus of x into x, that is u and v. Okay. The first fundamental form we are going to say E is that is xu and xu, f is u and v, and g is v and v. The second fundamental forms contains EFG with the normal n into uv, uu, and then uv, then vv. And the resultant is given like this. So these are the important formulas, what we are very, very basic thing, the multiplication and the modulus in the base. Very basic mathematics is used here. But the importance of this one, the application of this one is very powerful. When we go for the length, we are going to say integration square root of square and to this one. So area is given by the double integration. So area along the curve is double. This is length. Length means single integration. Area means double integration. When we go for the Gaussian curvature, we use this formula, EGF. What is EGF? In the previous, I have shown you E is this one, F is this one, G is this one. So this is EGF. Okay. Sorry, EGF. So mean curvature is given by this one. So these are the formulas from where we are. So formula based the calculation we can do it. But the thing is, when you are going to set it, that is along the normal or perpendicular to the normal, or the normal itself works that one, this we have to see in our this one. For example, I have taken a sphere like this. So this is theta, this is phi. Okay, so x theta phi can be written like this, as usual, what I told you, x, y, z. Now x theta and x phi is going to form like this. E, F, G is going to use the formulas which we are given in the previous, and we get E is some r square, F is 0, G is r square sine square theta. Okay, by this, by that formula, using that formula, for example, sphere, we can have the n and this one and all these EFGs, and we can go for the calculation of the length and the area, and all area is going to give by the 4 pi r square. All area is going to give by the 4 pi square. So this is the thing what we are going to, the important point is some type of imagination in the physics direction, some imagination, and what is going to be happen when you have a multiplication, when you have a parallel, when you have a normal, that knowledge should be there here when we deal with the differential geometry application, and some analysis type of mathematics is there. Now, GC and MC is given. So this is 1 by R as usual, the formula we have used to get it. So estimate normal and curvature of polygon mesh model. So what is this one? Normal means weighted average of normals of an adjacent face, that is fit plan. What is curvature? Fit circles and kappa is the curvature, kappa n cos phi. Curvature tensor is given like this. Curvature tensor is given like that. What is this one? What is this one? What is the tensor representation? This is tensor decomposition or tensor representation. What is tensor representation? Points can simply be represented by their coordinates. Points can simply be represented by their coordinates. A local description of a curve is given by the point coordinates, and it's a local description of a surface patch is given by a point coordinates and its associated normal. Here, however, we do not know in advance what type of entity, point, curve, surface, a token may belongs to. Furthermore, because features may overlap, a location may actually correspond to multiple feature types of the same time to capture first order differential geometry information and its singularity. A second order symmetric tensor is used. Second order symmetric tensor is used. It captures both the orientation information and its confidence or silency. Silency is also a part in the engineering applications. Such a tensor can be visualized as an ellipse in 2D or an ellipsoid in 3D intuitively, the shape of the tensor defines the type of information captured for that, for example, point, curve, or surface element. And its size represents the silency. By perceptual silency, we means the perceived importance of structures such as surface, curves, junctions, regions. For instance, in 2D, a very silent curve element is represented by thin ellipse whose major axis represents the this figure you are going to see here, what I am going to describe, whose major axis represents the estimated tangent directions and whose length reflects the silency of the estimation. In 3D, a point on a smooth surface is represented by a tensor in the shape of an elongated ellipsoid, that is stick tensor, with its major axis along the surface normal. A junction of two surfaces is represented by a tensor in the shape of a circular disc, that is plate tensor, which is perpendicular to the curve's tangent. Alternately, the plate can be thought of as spanning the 2D subspace defined by the two surface normals. In the case of the surface junction, finally, an isolated point or a junction of a curve has no orientation preference, and it represented by a tensor in the shape of a sphere, that is ball tensor. This one, this is the thing going on here. Okay, any second order symmetric tensor therefore can be decomposed, that is tensor decomposition, can be decomposed in the basis tensors, stick, plate, and ball in the 3D case. The tensorial representation allows for a unified treatment or inlier of smooth structures, depth and orientation, discontinuous and noise before any hard discussions are made for the role of each point. This property is extremely useful in perceptual grouping. Perceptual grouping, when the role of a point cannot be determined accurately from the initial data. Instead, the tensor represents the likelihood of all potential roles the point can play simultaneously. That is the importance of this one. Points can play simultaneously. Each point has its estimated normal, which is represented by the eigensystems. You can see this, whatever I have explained. This is ball tensor. This is stick tensor. This is plate tensor. These three I explained you. Okay, and these three put together, this is decomposition. This is the tensor, and this is the decomposition of the tensor. Okay, so this plays a very important role when we go in the application part of the things. So estimate normal using tensor voting. So when in machine learning, what we say, we can estimate the normal using tensor voting. What is voting? Voting is estimate normal from positions of receiver and voter and estimate normal of voter. Estimate normal from positions of receiver and voter and estimate normal of voter. That is the thing what we are going to do. You see the diagram on the screen. This is O, this is P, this is P, this is the curve. This is NO to P. See this one, NO to P. This is the beauty here. So estimate normal from positions of receiver and voter and estimate normal of voter. So O is the voter here. This P is like this. This is NP. This N is O to P. This is the beauty when we say this estimate normal using tensor voting. You see. Okay. Estimate curvature using tensor voting. This is curvature. Now see, point on the unknown surface gets maximum silency. Point on the unknown surface gets maximum silency. For example, these points are there. So how to estimate the curvature tensor? 1 by 2 pi minus pi to pi kappa, and this all whatever we have previously used the formula, that is this one. So like this, we are going to estimate the surface using the voting method or using the tensor voting. This is radius hit. Okay, this is see how we are going to. So this red means it comes on the curve. Okay, so like what is the summary of this one? So when I say curvature of a curve curvature of surface, that is Gaussian surface mean curvature. These parts we are going to see in this one. Gauss map, extended Gauss image, application of EGI. These three you can see. Gauss mapping. What is Gauss mapping here? If you see the Gauss mapping, this is the curve, this is here, this is 1D shape. You please see the diagram on the screen. So Gauss mapping for these two. So this is the two. Gauss mapping means it goes like this, 1D. When you see this one, this Gauss go for a 2D like this. Okay. What is this? Yes, S is a subset of R cube, be a surface with an orientation N. Orientation is needed here. And the map N S to R cube takes its value in a unit sphere, that is S square, and this XYZ, which is X square plus Y square plus, because it's a sphere, X square plus Y square plus Z square is 1, with N is XYZ. The map S to S square is called Gauss map. This map is called a Gauss map. That is the Gauss map. And you can see a 1D, one dimension Gauss map and 2-dimension Gauss map. Okay. This is 2-dimension Gauss map. This mapping. So extended Gauss image, this is very, very important application which the engineers are using in electronics and communication engineering by the electrical people and the computer science people. So distribution of normal represented in the spherical coordinates. For example, if it is expressed the area of a surface having the given normal. For example, this is the thing. It goes to like this. Now the distortion is going on. So characteristics of E. What is the characteristics of EGI? Means extended Gaussian image. Okay. So EGI is the necessary and sufficient condition for the convergence of the polynomial. Ratio between the area on the Gaussian sphere and the area on the object is equal to Gaussian curvature. EGI mass on the sphere is the inverse of Gaussian curvature. Mass center of EGI is the origin of the sphere. An objective rotates, then EGI of the object also rotate. EGI means, already I told you, image, extended Gaussian image of the objects also rotates. However, both rotations are same. Both rotations are same. These are the characteristics of the EGI. Relation between EGI and Gaussian curvature. This is object, this is Gaussian sphere. See this one, object, Gaussian sphere. See this one, large, this is small. It means delta S by delta O, this is needed. This is delta O tends to 0. The same thing here, very small. See here, K large. When K is small, this is the thing. When K is large, this will be large. Okay. When this is large, this is small. It depends on the thing. So relation between extended Gaussian image and Gaussian curvature is like this. Gaussian curvature and EGI maps. So this is the Gaussian part, and you see this delta O and how we are dealing with this one. So it's a very basic mathematics we are going to see through diagram is what is the direction, whether it is normal to that one or whether it is parallel to that one. For example, this, see this one, this all corners are going to see like this, and delta S is given like this. So what is that? Since NU and NV exists at the tangential plane at X, we can represent them by a linear combination. Linear combination of vectors, I think all of us know. So we are going to represent as a linear combination of these two. And then we are going to see what is the determinant of so and so. So like this, Gaussian curvature and EGI maps can be seen. And this is the mathematics behind all this one. That is NU dots this one. What is happening? You multiply to X. When you multiply NV to X, when you multiply NU to V, this all things E, F, G we are going to calculate, and then we are going to say what is the EGI map. EGI map is 1 by K. Like this we are going to calculate. Implementation of EGI, when we say the implementation of EGI, for example, see here the football I'm going to show you. So have a same shape, occur in a rectangle. Geodesic dome, what is geodesic? So geodesic, I already told you, preserving in mathematics, especially in differential geometry, a geodesic map or geodesic mapping or geodesic demomorphism is a function that preserves geodesics. So what is geodesics? Angle preserving. What you say in mathematics, a conformal mapping is a function that locally preserves angles, but not necessarily lengths. Okay. So when we say geodesic preserving, so that is the thing. When we say geodesic dome based on a regular polyhedron. So this is like this. Semi-regular regular geodesic dome is this one. Let us see. Example of EGI. If you see this one, this is side view. This is top view for the cylinder. For ellipsoid, this is the thing when you see the view. Top view, side view, and top view. See the difference when we are going to see. So how we can use, how we can make it this one to the application part through differential geometry. And very simple inputs we are, very simple mathematics inputs we are going to give to the machine. So determination of altitude using EGI. So altitude is also viewing. For example, someone is viewing, you see this one. So viewing direction, table is there. You can map map in this way to see the altitude, what is the angle, what is the shape, and how you can get it. So these are all known as a very simple and very powerful application of EGI to this one. Though no complex EGI is also there, which is known as CEGI. So complex weight will be there rather than the real. For example, if you see this one, this is the normal distance and area of a 3D object are encoded as a complex weight and associated with the surface normal, such that like this. This is NK, this is pi k, this is product of k, and this P is given by like this. This mathematics is going on. So this is a complex. Why it is complex? Objects are encoded as a complex weight. 3D objects are encoded as a complex weight. So complex EGI, Gaussian mapping in complex EGI is like this. You see this one, cube goes to CEGI of a cube. CEGI of a cube is like this. Okay, the weight is shown only for normal, N1 for clearly. Otherwise, we can show it for all. This is for viewing. It is well viewed in, if I show for only one normal N1. This is only shown for this one, this N1. Okay. Now see the what I told you, image processing type. See this one and see this one. See these two. What is going on? See, this was the thing. Now you observe, this is the thing going on. Okay, so that was due to that shrink or think we can do it in this one. We can do whatever we want according to the requirement of the application part. Okay, so bin picking system based on EGI. This is one of the application part. Photometric studio, segmentation, regional selection, photometric studio, EGI generation, EGI matching, grass planning. So needle map, isolated regions, target regions, precise needle map, EGI, object altitude. So this object attitude is there. Okay. Calibration, lookup table for photometric studios and hand-eye calibration. So see this one, as the Honorable Vice Chancellor was mentioning, the application of this differential geometry in the biological field. So this is the thing what we can do it amazing in that field, that is biofluids, biotechniques or bioinstrument type of thing. So this table for photometric studios, see this one, see this is the output, hand-eye calibration, you see this is the thing. So like this we can use photometric studio, you see better this one. Setup, this is the setup for this one. Okay, so bin picking system is like this. Okay, so these are the things what we are going to see. And if you want more and more this what you say differential geometry application part with about the EGI or about the CEGI, you can read a Horn book. Horn book, you can have it very good applications and very good things about the Gauss map, extended Gauss map, characterization, and all the things. So these are the things what I want to show you in this part, and you can read the Hornbook such that we can have it, how this Gauss map is going to work, how this differential geometry is going to work in the as an application part in different field of sciences and in different field of the real time problems or real time solutions for this one. So for example, we are personally, I am collaborated with the EC, electronics and communication engineer people. In the image processing, we are using this this type of what you say, this differential geometry, and the data science, in data science for analysis and to see the data and to separate the data and to make it the data as a shape, we are using this differential geometry. So I thought that for young mathematicians, is a very emerging field now, differential geometry and application part to artificial intelligence, machine learning, and data science. So if anyone is interested, you please go through the differential geometry basics and you may apply for any application part. It's a very beautiful and very emerging part now these days. So this was the thing what I want to speak in my talk. And now I request the students, particularly those who want to interact, or faculty, they can interact. Therefore, I have taken a time from 11 to 12:30, such that the talk and followed by the interaction, because today is Ramanujan's birthday and we are celebrating 133rd birth anniversary. So it is a time today I want to discuss, or I want to interact more and more to the students and those who are doing research in this field. Rather, I already told you, 20th and 21st century by the renowned mathematician Ramanujan sir. Now it is on us. It's a 133 year. Now it is on us now to make a mathematics useful and to make it something change application of a mathematics to the different fields. Therefore, I requested Revati madam to put it as 11 to 12:30 as talk and interaction. So rather than I can say you ask a question, you please interact and you tell your experience, those who have used this one or those who want to use this one, or you want to make a research on this field. Please, Revati madam, ask the participant to interact, please.
Dear participants, thank you, sir. Thank you very much. Thank you for your inspirable talk about Gaussian filters and curvature of surfaces, principal curvatures, parabolic points, lines of curvature, tensor representations, extended Gaussian images, which are most useful for engineering students. And this talk is very, very useful to the participants. Now, participants, dear participants, if you have any questions, please drop it in the chat box or directly.
Questions, or they want to interact, anything, please. Yes. Because today is just we have to talk less and we have to interact more.
Yes.
Because it's December. You can share.
Students or faculty? Anybody?
Any mathematics people. Please come up and discuss.
So there are no questions in the chat box also, sir.
No, not questions.
If
they want to discuss
yes,
or they want to present their views on this occasion. This is a National Mathematics Day now. Yes. So if they want to have it there, some experience, those who have applied mathematics for the application part or a bit, they can share. Participants. Students is also there, na, as a
Yes, sir.
participant.
Yes, sir. Yes, sir.
Yeah, so students can talk, na. Students can talk. Ask the students or anyone if they want to interact, they can interact.
Yes,
If
sir.
no, otherwise it's upon you. That's
Yes,
why
sir.
I given a slot to you from 11 to
Yes, sir.
12:30.
Yes, sir. ఫ్యాకల్టీ మెంబర్స్ ఎవరైనా ఇంట్రెస్ట్గా ఉంటే క్వశ్చన్స్ అడగండి. శ్రీనివాస్ సార్.
They can express their experience, those who have applied, that is those who have used the mathematics for some real type problem or some application part.
Sir, one faculty member came, sir.
Yeah, please.
Morning, sir. Keshav Reddy garu.
Morning, sir. Morning.
What is the difference between geodesic dome and Archimedean solids? Do you find any difference between them?
Which sir? Which sir? Please. Once again.
Geodesic dome.
Yeah, geodesic dome.
Yeah, and Archimedean solids.
Yeah. See, when you go for the Archimedean solids, we are going to define a geodesic dome actually. So it means when you go for Archimedean part, it is something bigger than this geodesic dome. So it's just a subset of that one. But in some cases, we have to make it convenient to a geodesic dome to be as a subset of that one. That is the difference.
In graph theory, we generally follow the Newton's law, that is number of faces, number of vertices, and number of sides relation equal to 2.
Yes.
Do you accept that geodesic dome also obeys this formula?
No.
So I think it would be more appreciable generalized and the Archimedes. If we go by Archimedean solids, I think
yes.
So
that's why I told you this face recognition, image processing in computer science people, they are going with this one now these days. Previously graph theory it's okay.
Yes.
Yes, please.
In some
please, sir,
in some other context, I found the normals drawn to the surface, where we generally in the two variable analysis, what we do is when the determinant is equal to 0, we fail to find the curvature of the surface at that point, saddle points.
Okay.
So I couldn't find the saddle points in your discussion, sir. Can you elaborate?
No, I told you now that dot is 0 somewhere. I have shown in my this one saddle point.
K greater than 0, K less than 0 are the discussions we had. But what happens when K is equal to 0?
Yes, I will show you. That is plane. I have shown.
Yeah, I think planar. Exactly. Right. And one more thing, sir. You have shown that n normal.
Yes.
The cross product with the normal along u bar and along v bar.
Yes, v bar. Yeah.
And all the three normals are shown in the same direction as n bar did.
Yes.
But I think parallelogram law is to be used there.
But it is a different case, no? I have shown for a different cases, I think. I will show you. I will show you that. This one, I think, no? This one you are asking.
Yeah.
Am I right on the screen?
No, sir.
Yes.
Yeah, this one, the previous screen.
Yeah, this one?
The next one, sir. Next.
Okay, this one.
The figure is showing that, yeah, this one.
Yeah, this you see the figure here. So when you see the mathematics now, when we make a figure of that one, it will be clear. So you can see.
Yeah.
This is
what I feel is n bar plus n bar, just like a bar plus b bar is the parallelogram law which we apply. So here also, I think parallelogram law is to be applied.
Yes, definitely. It will be satisfied.
And sir, about the gas mappings,
mapping.
When the surfaces have the poles, how the mapping acts on that?
Yes, that is the beautiful question. So when you have a poles, you are seeing this one, this Gauss map, right?
Yeah.
This Gauss map. So when you have a poles, we have to make it that one first to have a Gauss map, and then we have to proceed. That is the technique where the EEE people, that is electrical engineering people are using poles and zeros wherever they have. They are going to first make it convenient, that one, and then they are going for a Gauss map. That is the fundamental thing we are going to use there.
I think it is a research topic if the poles of order n is applied for this Gauss map.
Exactly.
Thank you, sir.
Exactly.
Thank you for your elaborated
Thank you very
elaboration
much.
on the discussion.
Thank you. Okay, anyone, Revati madam, please check it.
Yes, sir.
If anyone is there.
Yes, sir. I am checking, sir. No, sir. Sir, one question in the chat box.
Yeah.
In sports biomechanics, the human movements pattern is the theory applicable for sports interventions to enhance their skills.
Yes,
Nagendra
they are doing.
Kishore.
Yeah, what the thing is, Nagendra, what the thing is, you are seeing now these days lot of animated movies, animation and animated movies. So that animated movie, when they are going to make it an image and like that, they are using this technique to make it a code. For example, animated football you are going to see. So in that one, they are using this technique. Now recently, from last year it is started, because the beauty you can have, because the 3D part is there. So they are using this technique to make it a code for the animated movies. It is happening in the sports also. Yes, Nagendra Garu, it is used. Yeah, Revati Garu.
Clear, sir, questions, sir.
Okay. So I want to make the students much more interest, because you have a BSc and MSc in your affiliated colleges and your university.
Yes,
so the engineering students may not have a elaborated study this one, because they doesn't have in their course. But the BSc and MSc students can read this one and make it the application part. This one, that is the future of that one. So that makes a very important thing, that mathematics people can have a industry type of experience, means they are going to make it application part of this one to the engineering people, because they are not studying in elaborate form. But this differential geometry we have in a PG and UG course. If I remember, I think you have a differential geometry portion in your UG. So they can study in elaborate in the application type of part to get it, the applications. So therefore, I thought that why not we give it to the students that they can be alert, because after studying, if they are going to think now I will study, it's not good. So in the beginning itself, they can have it this type of orientation to the application, to the real world problem, real life problem, real time problems.
Sure, sir.
Okay, Revati.
Yes, sir. So thank you very much, sir. It's a great privilege to hear, sir.
Thank you, Revati.
It's a great opportunity to our students, sir. Thank you so much, sir.
And I thank Honorable Vice Chancellor, Registrar, and your university official, Department of Mathematics, Adi Kavi University, for giving me this opportunity to speak on the great occasion, Sir Srinivasa Ramanujam birth anniversary. So I'm thankful to you, Revati, particularly to Dr. Revati. Thank you, Revati.
Thank you, sir. Thank you so much.
Thank you.
Now I welcome Dr. G. Nanaji, sir, Head of the Department, Andhra University. I request Dr. V. Malipriya, one of our colleagues, to introduce Dr. G. Nanaji, sir. Madam, go ahead.
Thank you, ma'am. It's my privilege to introduce another speaker, Dr. G. Nanaji Garu. Dr. G. Nanaji Garu is an associate professor from Department of Mathematics, Andhra University. He did his PhD from Andhra University in 2001. He was an CSR Senior Research Fellow from 2000 to 2003. His research area is lattice theory. He taught commutative algebra, linear algebra, discrete mathematics, lattice theory, graph theory, modern algebra, universal algebra, Banach algebra, etc. He also taken classes for CSIR, UGC, JRF, NET coaching during the academic year 2009-10 for the students of Department of Mathematics and Department of Statistics and Department of Applied Mathematics. He was invited for a number of guest lectures. His professional membership includes member of Doctoral Committee, Department of Mathematics, Andhra University, member of Departmental Committee, Department of Mathematics, Andhra University, member of Departmental Research Committee, Department of Mathematics, Andhra University, member of BOS, Department of Mathematics, Andhra University, member of RUSA from Andhra University, member of World Ranking Team from Andhra University, life member of Andhra Pradesh Society for Mathematical Sciences. He acted as an paper setter for MSc Mathematics subjects from different universities. Also, he is an adjudicator for PhD thesis from different universities. He is also a member of Viva Voice Committee. He published nearly 33 papers in international journals. He is also reviewer for Mathematical Reviews, American Mathematical Society, USA. He is a referee for an international journal, Southeast Asian Bulletin of Mathematics. He is an referee for an international journal, Asian European Journal of Mathematics. He also represented 7 papers in international conferences. He also gave an endowment lectures, that is a lecture on quasi-complemented almost distributed lattices at APSMS during 9th December to 11th December 2016 at Nellore. He attended as a resource person for training program on Inspire 2006 and delivered a lecture on applications on Boolean algebra at Srikakulam. He attended as a resource person at National Seminar on Recent Developments in Engineering Science and its Computational Applications, Vijayawada, and delivered a lecture on Boolean algebra. He attended as an invited speaker at National Seminars, 23rd Congress of APSMS, 26th APSMS, UGC-sponsored 2-day national workshop in November 2019 at Acharnagar University, Guntur. He presented nearly 7 papers at APSMS conferences. Coming to the projects, he is the co-investigator for UGC major research project entitled Sheaf Representation of Stone Almost Distributive Lattices and Applications in Computer Science from 2012 to 2015. He organized an international conference as an organizing secretary on International Conference on Algebra and Application 2014 on 29th April to 1st May 2014 at Department of Maths, Andhra University. Under his supervision, 3 part-time and 6 full-time scholars awarded PhD. Among them, 2 are from Ethiopia. Under his guidance, 7 candidates awarded MPhil, both full-time and part-time. Presently working PhD students are 4 members, MPhil students are 3 members. Not only in academic and administrative, SAR is also active in extra activities like he got 2nd place in cricket conducted on the occasion of Science College Day celebrations in 2015 and 2016. He is also a winner in cricket conducted on the occasion of National Science Day celebration 2018 from Andhra University. I hope you will enjoy this session and be ready with all your careers. Thank you for giving me this opportunity. Over to Ravati ma'am. Thank you, ma'am.
Thank you, Dr. Malipriya madam.
Thank you.
Now I request Dr. G. Nanaji sir to deliver your talk, sir.
Thank you very much, Malipriya madam, for your nice introduction about me.
Thank you, sir.
And first of all, I thank the chief guest of today national webinar, Vice Chancellor Professor M. Jagannath Rao garu, and chief patron Professor B. Ganga Rao garu, and Ramaneswari madam, Principal, College of Science and Technology, and particularly Dr. K. Ravati madam, convener of this webinar, and other members of the department, Srinivas Rao sir, and Malipriya, KVM Varakumar, G. Ashok, Geeta Lakshmi, and of course, Sujata. Actually, she is our student. From actually, she is completed his MSc in Andhra University and PhD also, and other teaching and non-teaching and students, research scholars. So first of all, good morning everyone, and particularly our speaker, first speaker, Professor Keshav Reddy garu. Thanks for your nice lecture, particularly for the young research students. So I think it's very useful for the young research students. And today my talk is, so I think the students are aware on lattice theory, particularly, madam?
Yes, sir.
Files వెళ్ళాలి కదా, స్క్రీన్ షేర్లోకి వెళ్ళాలి కదా మనం. షేర్
స్క్రీన్.
ఎస్, షేర్ స్క్రీన్కి వెళ్ళి
now you can click a share.
Yeah, already I clicked, sir.
Yeah, then now you can open whatever document wherever it is. Okay. Now your screen is seeing everyone. No problem.
Okay. ఈ వెబినార్స్ వచ్చిన తర్వాత, థ్యాంక్ యూ.
Now you can make it full view పెట్టుకోండి సార్.
ఫుల్ వ్యూ పెట్టుకోండి.
వ్యూ లోకి పోయి you make it full screen.
ఇక్కడ yes. Okay, sir.
Yeah.
No, it's okay.
Now you can make it full view. No problem.
Full screen పెట్టండి.
Full screen పెట్టేస్తే వచ్చేస్తుంది.
ఫుల్ స్క్రీనా?
మాక్సిమైజ్ చేయకుండా ఫుల్ స్క్రీన్ అని పెట్టేసింది సార్.
నేను ఇది ఇక్కడ ప్లస్ సింబల్ ఉంది, దాని మీద నేను
ప్లస్ అంటే అది పెద్దది అవుతుంది. ఫుల్ స్క్రీన్ అంటే ఇట్ విల్ బి అడ్జస్టెడ్ ద టోటల్ స్క్రీన్.
ఫుల్ స్క్రీన్ ఎక్కడండి అది?
రైట్ కార్నర్ లో టాప్ కార్నర్ సార్.
రైట్ టాప్ కార్నరా?
వ్యూ ని క్లిక్ చేస్తే వ్యూ కింద ఫుల్ స్క్రీన్ వస్తుంది సార్. మీ వ్యూ VIEW.
అదే వ్యూ ఇక్కడ ఏం కనబడట్లేదు నాకు.
మీరు ఇప్పుడు ఇది ఓపెన్ చేశారు కదా సార్, దాంట్లో లెఫ్ట్ లో అన్ని పైన ఉంటాయి, ఫైల్ వ్యూ అన్ని ఉంటాయి అన్నమాట.
ఒక్క నిమిషం చూస్తున్నా.
హలో సార్, మీరు బ్రౌజర్ లో ఓపెన్ చేశారు సార్, దానికి
బ్రౌజర్ లో ఓపెన్ చేయొద్దు సార్.
మీరు కింద డౌన్లోడ్ ఉంది కదా సార్, ప్లస్ సింబల్ పైన డౌన్లోడ్ చేసుకోండి సార్.
డౌన్లోడ్ చేయాలి కదా?
చేసుకోండి సార్. ఓకే, అప్పుడు ఎక్కడ చూడండి, సేవ్ చేసుకోండి సార్.
ఓకే, ఇది డెస్క్టాప్ ని సేవ్ చేద్దాము.
డెస్క్టాప్
సేవ్ ఇట్.
ఫైల్ ఓపెన్ చేయండి సార్.
మళ్ళీ అక్కడికి వెళ్ళి ఓపెన్ చేసేయచ్చు కదా?
అక్కడికి వెళ్ళి
ఇది ఆల్రెడీ డెస్క్టాప్ మీద ఉంది సార్, మీది
డెస్క్టాప్ మీద ఉంది.
పర్లేదు సార్, ఓపెన్ చేసేయండి సార్, ప్రాబ్లం
లేదు. ఓపెన్ అనుకోండి.
ఓపెన్ అని కొట్టండి సార్.
ఇప్పుడు చూడండి వచ్చిందా?
ఓకే సార్, మీ దాంట్లో PDF లేనట్టుంది సార్, అడోబ్ రీడర్ లేనట్టుంది సార్.
లేదా ఒక పని చేయండి సార్, మీరు దాని మీద రైట్ క్లిక్ చేసి ఓపెన్ విత్ అడోబ్ రీడర్
అని క్లిక్ చేయాలి.
ఓపెన్ విత్ సిస్టమ్ రివ్యూయర్ అని ఉంది.
అది కాదు సార్, ఫైల్ ఓపెన్ చేయండి సార్. ఫస్ట్
ఫైల్ మీద క్లిక్ చేయండి, ఇది క్లోజ్ చేయండి సార్.
ఇది క్లోజ్ చేశానా? ఓకే.
రైట్ క్లిక్ పెట్టండి అక్కడ.
ఇది కాదు సార్, ఇది మినిమైజ్ చేసేయండి సార్.
ఇది మినిమైజ్ చేసేయండి సార్. ఇది
ఇప్పుడు నేను డైరెక్ట్ గా డెస్క్టాప్ మీదకి వెళ్ళిపోతాను.
దీని మీద మీరు రైట్ క్లిక్ చేయండి, రైట్ క్లిక్.
ఓకే.
ఓపెన్ విత్ అని వస్తుంది చూడండి.
ఇప్పుడు వచ్చిందని చూడండి. ఇట్స్ ఓకే.
ఇట్స్ ఓకే, ఫైన్, నో ప్రాబ్లం.
ఇట్స్ ఓకేనా?
ఓకే సార్.
1 minute, జస్ట్ మినిట్ మేడం, ఒక్కసారి మా స్టూడెంట్ పిలుస్తాను. 1 minute.
నో ప్రాబ్లం సార్, నో ప్రాబ్లం.
అరవింద్ ఒకసారి డ్రామా ఇది కొద్ది ఇది పెట్టాము, ఇది వ్యూలో పెట్టమంటున్నారు. ఒకసారి చూడండి, నేను వెబినార్లో ఉన్నాను. వ్యూ పాయింట్ ఎక్కడ ఉంది?
బిగ్ స్క్రీన్ చేయమని.
బిగ్ స్క్రీన్ చేయమంటున్నారు మేడం. ఏంటన్నారు?
బిగ్ స్క్రీన్ చేయమని. ఫుల్ స్క్రీన్ చేయమని.
ఇది క్లోజ్ చేసేస్తారా, లేకపోతే డెస్క్టాప్ నుంచి పట్టుకొద్దామా? అక్కడ క్లోజ్ చేసేసి. ఓకే, ఇప్పుడు ఇది నా ఫైల్. యాక్చువల్లీ ముందు వెబినార్లోకి వెళ్ళిపోదామా? ఇది ఫుల్ స్క్రీన్ చేయమంటున్నారు. ఫైల్లోకి వెళ్తారు కానీ వ్యూ పాయింట్ ఏదో ఉంటుంది అక్కడ. వ్యూ లోకల్ ఆర్ షేరింగ్, అది నొక్కండి. అదేంటది కాదు, ఒకసారి క్లోజ్ చేసేసి మళ్ళీ వెళ్దామా?
నానాజీ సార్, ఫైల్ క్లోజ్ చేయండి ఒకసారి.
ఫైల్ క్లోజ్ చేసేయండి. ఫైల్ క్లోజ్ చేసేయండి.
ఇప్పుడు రైట్ క్లిక్ చేయొద్దు, మీరు డబుల్ క్లిక్ చేయొద్దు, రైట్ క్లిక్ జస్ట్ ఇట్లా క్లిక్ చేయండి అంతే.
రైట్ క్లిక్
రైట్ క్లిక్ చేస్తే
వ్యూ అని ఉంది.
దీని మీద
ఫైల్ మీదకి వచ్చేసి
ఫైల్ మీద రైట్ క్లిక్.
ఓకే,
ఈ ఓపెన్ విత్ ఉంది చూడండి లాస్ట్ లో. ఓపెన్ విత్ అడాబ్ రీడర్. ఓపెన్ విత్ పైన అడాబ్.
ఓకే, ఐ సీ. రైట్.
ఇప్పుడు వ్యూ ఉంది చూడండి, ఇది క్లోజ్ చేసేయండి.
ఇది క్లోజ్ చేశానా? ఓకే, ఇది డిక్లైన్ చేస్తాను. ఇది డిక్లైన్ చేసేస్తాను. ఇది
డిక్లైన్ చేసేయండి.
ఓకే, ఫిట్ మళ్ళీ పోయింది.
Open with.
ఓకే.
Adobe, yeah.
ఇది ఏదో వస్తుందండి మధ్యలో.
అది క్లోజ్ చేసేయండి సార్. ఇది డిక్లైన్, యాక్సెప్ట్ డిక్లైన్ ఇట్.
డిక్లైన్ చేస్తే బ్యాక్ ఆర్ క్విట్.
ఆర్ యూ షూర్ వాంట్ టు డిక్లైన్ ద ఎండ్ యూజర్ లైసెన్స్ అగ్రిమెంట్
అని అడిగింది.
You must accept the end user in order to use this product. Okay. To go back and accept the agreement, select the back button.
Go back.
Go it back. Accept చేసేసేయండి సార్. Accept it.
Okay.
No పెట్టేసేయండి. No. Now view లోకి పోయి వ్యూ ఉంది చూడండి.
వ్యూ ఉంది ఇక్కడ.
ఫుల్ స్క్రీన్. ఇది ముందు నో పెట్టేసేయండి ఇక్కడ. నౌ వ్యూ లో ఫుల్ స్క్రీన్. వ్యూలో ఫుల్ స్క్రీన్ ఉంటుంది చూడండి. కింద ఇంకా పైన. Now it's okay.
Okay, thank you. Okay sir, thank you very much. మనకి కంప్యూటర్ దీంట్లో కొద్దిగా నాలెడ్జ్ తక్కువ.
ఏం పర్వాలేదు, మ్యాథమెటిక్స్ వస్తే చాలు సార్.
మ్యాథమెటిక్స్ ఈ మధ్యని ఆన్లైన్ క్లాసులు వచ్చిన తర్వాత కొత్తగా నేర్చుకున్నాం అండి, అది మెయిన్. ఓకే సార్, థ్యాంక్ యూ వెరీ మచ్. ఓకే డియర్ స్టూడెంట్స్, పర్టికులర్లీ స్టూడెంట్స్ from MSc? Students?
Yes, sir. Students from MSc and BSc also, sir.
Okay. So we'll interact later, okay, after the lecture. Okay, madam. Today, my lecture on quasi-complemented distributed lattices. Basically, the background of the lattice theory is already everybody knows that in very fundamental in mathematics we know the relations, the relation, function definition, then we know different types of relations like symmetric, reflexive relation, symmetric relation, antisymmetric relation, and we have an equivalence relation and partial order relation, and then we can talk about the partial order relation on one direction, the equivalence relations on the other direction. So lattice theory towards partial order relations, and everybody knows that when BSc level, you know, the least upper bound and greatest lower bound for given set. According to that, we'll define lattice. So then there are kinds of lattices called modular lattices, distributed lattices, relatively complemented lattices, sectionally complemented lattices, and Boolean algebras. So these are all the developments from the poset. So very simple concept. The poset means it is a non-empty set together with a relation called partial order relation. That is any relation which satisfies reflexive, antisymmetric, and transitive is called a partial order relation. And you replace symmetric by antisymmetric by symmetric, we get an equivalence relation. And there is a beautiful theorem that, you know, partition of a set, that means a family of subsets whose union is equal to whole set and pairwise disjoint. And what is the relation between the equivalence relation and a partition means whenever there is an equivalence relation, we have equivalence classes, and those equivalence classes, they form a partition. So that is one direction. On the other direction, we have a partial order relation. From that, we talk about the least element, greatest element, minimal element, maximal element, and upper bound, lower bound, least upper bound, greatest lower bound. All these are fundamental concepts for lattice theory. And then we have a chain definition and lattice, complete lattices. Already I told you modular, distributive, and relatively complemented lattices. There is a lot of things going on. So this is already long back. This distributed lattices concept was already developed long back. And in 1980s, Professor U.M. Swamy and Chakradhar Rao garu, they introduced the concept called almost distributed lattices. That means it's a very near to distributed lattices, but not the distributed lattice. And almost satisfies all the conditions of distributed lattices except the commutativity of join and commutativity of meet. So this is a beautiful structure, almost distributed lattices. Lot of work done on this concept. So more than, I think more than 20 PhDs awarded on this concept. And later on, it is my turn after my guide. I introduced this concept quasi-complemented distributed lattices. Already quasi-complemented lattices is already there. It's a great mathematician called Cornish was introduced. And keep it in mind, one of my student and myself introduced this concept called quasi-complemented distributed lattices. Okay. So students, particularly MSc students, I think you have a course on lattice theory, discrete mathematics in your MSc. I think you know what is the definition of a poset, a chain, lattice, the modular lattice, distributed lattices. All those things already you know, and ideals and filters also is there. Okay. So this is also running on such concepts. Okay. Sir, Kesareddy garu. Sir. Ravati madam. Hello.
Sir, sir.
ఈ స్క్రీన్ మీద ఇది ఈ పైన సగం క్లోజ్ అవుతుంది. ఇది ఎలాగ ఇది
స్టక్ అయిపోయింది సార్. ఇది
ఇది సగం మన నేమ్స్ వస్తున్నాయి.
అది మీరు నేమ్స్ వస్తున్నాయా?
సగం క్లోజ్ అవుతుంది ఆ మ్యాటర్.
అవును సార్. హాఫ్ కనిపిస్తుంది సార్.
కాదమ్మా
సార్,
ఇది మీరు ఇందులో నేమ్స్ కొన్ని కనబడుతున్నాయి ఇందులో.
ఓకే ఓకే, అంటే అది మీరు చార్ట్ ఓపెన్ చేసి ఉంటారు సార్. చార్ట్ క్లోజ్ చేసేయండి సార్. చార్ట్ ఓపెన్ చేసి చార్ట్ దగ్గర క్లోజ్ చేయండి సార్. కింద చార్ట్ ఉంది కదా.
ఏది నాకేం కనబడట్లేదు ఇక్కడ.
స్క్రీన్ పైన డబుల్ క్లిక్ చేయండి సార్. స్క్రీన్ మీద,
స్క్రీన్ పైన
స్క్రీన్
ఇది స్క్రాల్ అయిపోతుంది. దీని మీద డబుల్ క్లిక్ చేయనా?
రైట్ సైడ్ ఫుల్ స్క్రీన్ పెట్టండి సార్. లేకపోతే
okay, now it is okay. Okay, so this is actually the introduction of my talk. In 1973, W.H. Cornish introduced the concept of quasi-complemented lattices and proved many important properties of this concept. And also the concept of ADL means almost distributed lattices was introduced by our department professors, Professor U.M. Swamy and my research director, Professor Chakradhar Rao garu, who observed that every maximal element is dense, but a dense element need not be maximal. Dense element means, for example, in lattice, suppose x meet A is 0, then we know that such elements are denoted by x star, bracket x star. If Baker's x star is singleton 0, then such elements are called dense elements. So in ADL, observe that every maximal element is dense, but a dense element need not be maximal. With this motivation, we introduced the concept of quasi-complemented almost distributed lattice and observe that if L is quasi-complemented ADL, then X is quasi-complement of X if and only if Y is the quasi-complement of X. Because In ADL, join is not commutative and meet is also not commutative. So that this is an observation. We gave certain examples of quasi-complemented ADLs, and we introduced the concept of uniquely quasi-complemented ADL and gave certain examples of uniquely quasi-complemented ADLs in this lecture. We proved that if L is an ADL with maximal element, then the set of all maximal elements in L is a quasi-complemented ADL, and observed that in quasi-complemented ADL, every dense element is maximal. Every dense element is maximal. Next. In quasi-complemented ADL, we observed that every dense element is maximal, and proved that if Y is quasi-complement of X, then bracket X star is equal to bracket Y. Okay. We proved that every quasi-complemented ADL is a star ADL, and observed that the converse is not true. Also, we derived a necessary and sufficient condition for a star ADL to become quasi-complemented ADL, and proved that a uniquely quasi-complemented ADL is a Boolean algebra. So students are already aware of on Boolean algebra. We proved that L is quasi-complemented ADL if and only if PAL means the set of all principal ideals in ADL. That is already proved that it's a lattice. So this PAL is a Boolean algebra, and it derived a set of equivalent conditions for an ADL to become quasi-complemented ADL. So in this lecture, we observed that the concept of prime ideals and annihilator ideals are independent in ADLs and characterized quasi-complemented ADLs in terms of prime ideals. We proved that if every prime ideal in an ADL is an annihilator ideal, then every prime ideal is a maximal ideal, and hence derived a necessary and sufficient condition for an ADL to become quasi-complemented ADL. We proved that if every ideal in an ADL is an annihilator ideal, then L is quasi-complemented. So these are certain preliminaries which are more useful in the coming test. So this is very, very important concept, almost distributed lattice. Our students already, they know distributed lattice. I think in lattice theory, there is a distributed lattice definition. But here, this is the this concept called almost distributed lattice, abbreviated as ADL, is an algebra of type 2 to 0. The 2 to 0 means you know the RT numbers. In standard textbooks, type means these are the RT numbers. RT numbers means because an algebra means it is a non-empty set together with a set of fundamental operations. You know, in groups, there is a binary operation. Already you know what's a group definition. There is a binary operation. Binary operation means suppose G is a non-empty set. Any function or mapping from G cross G to G. That is a binary operation. It is denoted by 2. That 2 is called an RT number. But in group, there is a unary operation called inverse. Because in group, every element has inverse. It is a map, we can treat it as a mapping from G to G. That is a unary operation that is denoted by 1. And we know that it's a fixed element called identity element. It is denoted by nullary operation. It is denoted by 0. So a group is an algebra of type 2, 1, 0. 2 means one binary operation. 1 means one unary operation in group inverse. And 0 denote the nullary operation. So therefore, group is an algebra of type 2, 1, 0. Okay, students? Particularly, I discussed about these concepts regarding students. Okay. Here, an algebra L join meet 0. That means this join and meet are two binary operations denoted by 2, 2, and 0 is nothing but a fixed element. It is denoted by nullary operation. Is called an almost distributed lattice with 0 if it satisfies these conditions. Number 1, you know this distributed law, A join B meets C is equal to A meets C join B meets C. But in distributed lattice, this is same as C meet A join B because meet is commutative, which is there. But here, this is not equal to C meet A join B, remember. Okay. And A meet B join C is equal to A meet B join A meet C. and A join B meet B is equal to B, and A join B meet A is equal to A, and A join A meet B is equal to A, and 0 meet A is equal to 0. But in lattices, because meet and join are commutative, this is same as you can write A meet A join B, A meet B join A, you have, because meet is commutative and join is commutative. We get many absorption laws, but these are the fixed absorption laws from this definition. Okay. So any algebra which satisfies these conditions, such algebra is called almost distributed lattices. This is a very important concept at present in lattice theory research in our department. Okay. And you know, the partial order relation, we define a less than or equal to. L means here ADL. A less than or equal to B means A meet B is equal to B, or equivalently A join B is equal to B. Okay, so then this less than or equal to is a partial ordering on L. Whether join is associative or not, still not known. Still not known in ADL. But in an ADL, the join, our ADLs are nothing but associative ADLs. That means join is always associative. Okay. Throughout the cell, ADL with 0 unless otherwise mentioned. Clearly, every distributed lattice is an ADL, but the converse need not be true, because we have an ADL definition. So every distributed lattice is an ADL, but almost distributed lattice need not be a distributed lattice. For example, this is an example. Suppose you take a non-empty set X and fix X0 belongs to capital X, and you take any arbitrary elements XY belongs to capital X and define meet X meet Y is equal to X0 if X is equal to X0, and Y if X is not equal to X0, and X join Y is equal to Y if X is equal to X0, and X if X is not equal to X0. Then clearly this is an almost distributed lattice, but not a distributed lattice, because here join and meet are not commutative. So this is a powerful example of an almost distributed lattice, which is not a distributed lattice. Okay. And also any non-empty set can be made it into an ADL. This is an example. And this is called, particularly the special name is called discrete ADL. Okay. And another important example, you take a commutative regular ring. Commutative regular ring. Regular ring means it is a ring that is R is a commutative ring with identity in which to each X belongs to R, there exists unique idempotent element X0 belongs to capital R, such that XR is equal to X0 R. Okay, now define for any XY belongs to R, X meet Y is equal to X0 Y, and X join Y is equal to X plus Y plus X0 Y. Then this is also an ADL, and this comes through regular rings. So these are certain examples of ADLs. Okay. Now already we have defined X less than or equal to Y is equivalent to X meet Y is equal to X, or equivalently X join Y is equal to Y. Then less than or equal to is a partial order relation, because in lattice we know that X less than or equal to Y if and only if X meet Y is equal to X. Okay. And also Y meet X is also equal to X. But here, because meet is not commutative, X meet Y is equal to X. Okay. And X join Y is equal to Y. But in lattice, Y join X is equal to also Y. But here, because join is not commutative, this definition is very important in ADLs. Okay. First, we prove that some simple properties in ADLs. In ADL, suppose X join Y is X if and only if X meet Y is equal to Y, and X join Y is equal to Y if and only if X meet Y is equal to X. That means if join is one of the element, then meet is the other element. That's as simple for remember. And commutativity holds only when those are comparable. If X less than or equal to Y, then X meet Y is same as Y meet X. But in lattice, we know that meet is always associative. But here in the definition, associativity of meet is not there. But we proved that meet is always associative in ADLL. And X meet Y meet Z is equal to Y meet X meet Z. There is no direct commutativity of meet, but here see, the right side Z is fixed, but we are commuting the left side elements. That means x meet y meet z is equal to y meet x meet z. In the same lines, x join y meet z is equal to y join x meet z. And x meet y 0 if and only if y meet x is equal to 0. And join is commutative whenever x meet y is equal to 0. And these are some special types of absorption laws. X meet x join y is equal to x meet y join y is equal to y, and x join y meet x is equal to x, and x meet y join y is equal to y, and x join y meet x is equal to x. And suppose, because already we have join is associated is not there, but associated of join holds whenever. So right side meet with some element. That means x join y join z is equal meet y meet w is equal x join y join z meet w. If suppose w is on the right side, we have join is always associated. And you know absorption laws. X meet x is equal to x, and x join x is equal to x, and x meet 0 is equal to 0, and 0 join x is equal to x. So these are the certain properties in ADLs. Okay, and and these are also some more. So x join y is equal to x join y. But in lattice, this is a trivial observation because in lattice join is always associative. So and using idempotency laws, you can remove this y join y. You can write y. But here, because associated of join is not there, but we prove these results. X join x is equal to x join y. And x join y is equal to x join y, x meet y is equal to x meet y, and x meet y is equal to x meet y, and y meet x meet y is equal to x meet y. And x join y is equal to x join y join x. These are certain properties in ADLs. And in ADL, L join meet, an ADL L join meet is said to be associative if join is associative. Okay. Anybody knows? Can you, you know the name Professor Senkapanawar, Universal Algebra? A great author wrote a book on universal algebra. Senkapanawar is a world famous universal algebra book who wrote by Senkapanawar. Because when they designed this ADL concept in 1980s, okay, already just we have seen join is associative or not in ADL, still not proved. But 1 year back, Professor Senkapanawar, he came to India and visited our department. And I discussed with Professor Senkapanawar that is it in ADL, join is associative or not, still not known. Please, sir, can you give an example of a non-associative ADLs? So one day night, we are sit together in a guest house from evening to next day morning 9 o'clock. Finally, he found an example that non-associative ADLs are there after 30 years. He solved that problem, Professor Senkapanawar. Heads up to Professor Senkapanawar. So he constructed an example that there are non-associative ADLs. From that day onwards, in ADL, join is one of the condition. Join is one of the condition. So an ADL means join associative is also a condition. Because whenever we introduce a concept with certain conditions, that first of all, you prove that all the conditions are independent. All the conditions are independent. Independent in the sense, suppose some definition consisting, for example, three conditions. Those three conditions are independent means you can give an example of 1 and 2 are one condition 1 and 2 are true but fails to 3, one example. Second, 2 and 3 are true but 1 fails. And 3 and 1 are true but 2 fails. So give 3 examples. So then we say that those 3 conditions are independent. But in ADL, we have more than 6 conditions. But these 6 conditions are independent. So these are examples given by Professor Swami and Chakradhara Garu. But after 30 years, Professor Senkapanavar sir gave an example that there are non-associative ADLs. That means it is an ADL, but which fails to join is associative. Understand? So therefore, from now onwards, an ADL means join associative is also one of the condition. Okay, last year he found that example. So we felt very happy on that occasion. Okay, so students, MSc students, particularly MSc students. Hello, 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 students, MSc students. Hello, is there anybody, MSc students? Okay. So now the next definition, you know that an interval in real answers also is there. For any AB belongs to L, A less than or equal to B, then bracket AB is equal to all X belongs to L such that A less than or equal to X less than or equal to B, which is called an interval. Clearly, every interval in ADL is a bounded distributive lattice. But in ADL, there are no commutativity of join and beat, but this interval is a bounded distributed lattice because already there is a corollary. Whenever 2 elements are comparable, then associativity of join, commutativity of join and commutativity of meet is always there, because you take any elements here, this is in between A and B. So therefore, this is a bounded distributed lattice. And an ADL is said to be relatively complemented. Already you know relatively complemented lattice. That means every interval is a sublattice. Here also, L is said to be relatively complemented if every interval is a Boolean algebra. Here, every interval is a Boolean algebra. And an element M is said to be maximal. As in posets, M less than or equal to X implies M is equal to X. And these are the equivalent conditions to say that an element is maximal. That means M is maximal, M join X is equal to M for every X belongs to L, M meet X is equal to X for every X belongs to L. So any one of these conditions implies M is a maximal element. So next we define an ideal and filters: principal ideal, maximal ideal, dense ideal, annihilator ideal, alpha ideal, minimal prime ideal, disjunctive ideal, and weakly disjunctive ideal. And also certain important results which are used in this text. You know ideal definition. A non-empty subset I of L is said to be an ideal. It is closed under join, and you take an element A in L and X belongs to Y. This X meet A belongs to Y. Remember, in lattice X meet A same as A meet X, but here X meet A belongs to. That is important. Okay. And a filter means is a non-empty subset which is closed under meet, and for any X belongs to F and A belongs to L, A join X belongs to F. Remember, A join X, not X join A. That's very important. A join X belongs to F. And it can be easily seen that every ideal and filter are subideals. Subideal means, it is closed under the operations. In general, in universal algebra sense, for any given algebra, subalgebra means it is a non-empty set. It is a non-empty set which is closed under every operation in the original algebra. That is universal definition. And that means for a group, there is a subgroup. For a ring, there is a subring. For a field, there is a subfield. For a lattice, there is a sublattice, something like that. So more general definition for given any algebra, subalgebra means it is a non-empty subset for given algebra, and which is closed under every operation in the original algebra. For example, suppose G plus is a group. What is a subgroup? You know, H is a non-empty subset of G, and H is closed under plus. Closed under plus means you take X comma Y belongs to H implies X plus Y belongs to H. That is closed. Closed means. So in that sense, it is closed under every operation in the given original algebra. That is called subalgebra. So here, every ideal and filter of L is a subideal. And an ideal filter of L is called proper, you know, it is not equal to whole of L. Okay. And these are certain definitions. So bracket X is equal to all X meet S is an ideal, which is called the principal ideal. And X belongs to bracket Y if and only if Y meet X is equal to X. And X meet Y belongs to Y if and only if Y meet X belongs to I, provided I is an ideal. Already you know ideal definition, there is only one direction, but if it is an ideal, X meet Y belongs to I if and only if Y meet X belongs to I. And principal ideal generated by, in general, in ideal, X meet Y is not equal to Y meet X, but principal ideal generated by X meet Y is same as principal ideal generated by Y meet X. And X belongs to Y and A belongs to L such that A less than or equal to X implies A belongs to Y. That means I is an initial segment. This condition says that I is an initial segment. So now, this is a theorem. This set IL of all ideals in ADL, they form a distributive lattice under inclusion, where for any Ij belongs to I of L. So simply meet is nothing but intersection. So intersection of any two ideals is again an ideal. But the join is nothing but all X join Y such that X belongs to I and Y belongs to J. So with these two operations, this I of L is a distributive lattice. Okay. Next one, these are some properties of principal ideals. Bracket X join, already join of ideals is already there. So therefore, the principal ideal generated by X join Y is nothing but principal ideal generated by X join Y, which is same as principal ideal generated by Y join X. But in general, X join Y is not equal to Y join X. But principal ideal generated by X join Y is equal to principal ideal generated by Y join X. In the same lines, bracket X meet bracket Y is equal to bracket X meet Y, which is same as bracket Y meet X. In the same lines for filters. So bracket X is equal to all A join X, such that A belongs to L is a filter. So this is called a principal filter generated by X. And this is an observation. X belongs to bracket Y if and only X is equal to X join Y. And same X join Y belongs to F if and only Y join X belongs to F, provided F is a filter. And these two are equal. Okay. And X belongs to F and A belongs to L such that X less than or equal to implies A belongs to F. Such condition is called final segment. Initially in ideals, there is an initial segment. Here, this is called a final segment. Okay. And this set of all filters, this is a theorem. The set of all filters of an ADL form a distributive lattice where for any two filters, meet is nothing but intersection and join is nothing but X meet Y such that X belongs to I and Y belongs to J. Join means, you remember in lattice, what is join and what is meet? X meet Y means that is the greatest lower bound and X join Y is the least upper bound. Here, I join J is nothing but least upper bound of I and J. That means this is the smallest filter containing both I and J. That is actually, this is the smallest filter containing both I and J. And some results on principal filters, bracket X join bracket Y is equal to bracket X meet Y. Here, this become reverse. Bracket X join bracket Y is nothing but bracket X meet Y, which is same as bracket Y meet X. And bracket X meet bracket Y is equal to bracket X join Y. So like meet goes to join, which is equal to bracket Y join X. Okay. And a proper ideal P of L is said to be a prime ideal. For any XY belongs to L, if X meet Y belongs to P implies one of them must be belongs to P. As simple in rings, you know, what is the prime ideal condition? Prime ideal means is a proper ideal in which X meet Y belongs to P implies either X belongs to P or Y belongs to P. So you replace product multiplication by meet. So you get a prime ideal condition in ideal. A proper filter P of L is said to be prime if X join Y belongs to P implies either X belongs to P or Y belongs to P. And of course, maximal, an ideal P of L is said to be maximal if it is not properly contain any proper filter. P of an ideal is said to be minimal if Q is any prime ideal of L such that Q is contained in P, then P is equal to Q. This, of course, these are all in already in lattice concept, and also distributed lattices are there. Okay. And every proper ideal is contained in a maximal ideal by using John's lemma. Already in lattice theory, you have a John's lemma. What is John's lemma says? John's lemma says that in a poset, if every subchain has an upper bound, then that poset has at least one maximal element. So using that condition, John's lemma, we proved that every proper ideal is contained in a maximal ideal. Okay. Every prime ideal in an ideal contains a minimal prime ideal. Every maximal ideal is a prime ideal. This is also valid in ring theory. Every maximal ideal is a prime ideal in rings also. Every prime ideal is, how we can prove that every maximal ideal is a prime ideal in ring theory? There are two theorems already. Those are proved in degree class also. You know, P is prime, the quotient ring A by P is an integral domain, and P is maximal if and only if the quotient ring A by P is a field. You know, and also we know that every field is an integral domain. Every field is an integral domain. So therefore, P is maximal implies A by P is a field, implies A by P is an integral domain, because every field is an integral domain, implies P is prime. So therefore, maximal ideal always a prime ideal. But prime ideal need not be maximal, you know, because, you know, in ring of integers, bracket 0, principal ideal generated by 0 is always prime ideal, but not a maximal ideal, because there are many ideals in between 0 and Z. Okay. So here every maximal ideal is prime in ideal also. But prime ideal is a maximal ideal provided it is a Boolean algebra. It is a Boolean algebra. Okay. Next, a subset P of an ideal L is a prime ideal if and only its complement is a prime filter. And every proper filter of an ideal is contained in a maximal filter. Same, every proper ideal is contained in a maximal ideal. In the same lines, every proper filter is contained in a maximal filter by using John's lemma. Okay. An ideal I of an ideal L is a minimal prime ideal if L minus I is a maximal prime filter. Okay. Next, if I is an ideal and F is a filter such that I intersection F is empty, then there exists a prime ideal P of L such that I is contained in P and P intersection F is empty. An ideal L is an ideal with 0. Then a non-empty subset A of L, for any non-empty subset A of L, A star, this is a set, it can be defined as all X belongs to L such that X meet A is equal 0 for all A belongs to A, which is an ideal in L and is called n-half ideal. It is called an n-half ideal. An ideal I of an ideal with 0 is said to be n-half ideal if I is equal to A star for some non-empty subset A of L, or equivalently I is equal to I double star. So this is the n-half ideal definition. Okay. It can be easier observed that every maximal element is dense, already we know, but a dense element need not be maximal. This is an example. You take two discrete ideals. Already I told you discrete ideal definition. You take two discrete ideals and suppose you take their Cartesian product. This is an ideal under component wise join and meet operation. Here put S is equal to, you skip in this part A0. You remove A0 from this, you call it as S. Then clearly S is a subideal of A cross B with maximal element AB1 and AB2. Now AB1 star is equal to 0, 0. Therefore, this is a dense element. Already I told you if star is singleton 0, it is always a dense element. But AB1 is not a maximal element. AB1 is not a maximal element. Okay. Now, we have introduced this actually, our concept called quasi-complemented almost distributed lattice. Actually, this is the motivation for our definition. This is every maximal element is dense, but dense element need not be maximal. So this motivates us to introduce a quasi-complemented almost distributed lattice. We have observed that every maximal element is dense, but dense element need not be maximal. With this, we are introduce the concept of quasi-complemented almost distributed lattice, and observe that same, if x is quasi-complement of y and y, if and only y is a quasi-complement of x, we give certain examples and results in this lecture. So this is actually the definition. An almost distributed lattice L with 0 is called quasi-complemented. If for each x belongs to L, there is an element y belongs to L such that x meet y is equal to 0 and x join y is maximal. X meet y is 0 and x join y is maximal. Here y is called the quasi-complement of x. Y is called, this is actually the definition. Okay. So now these are certain observations. If L is an ideal with 0, x meet y 0 if and only if y meet x 0. And x join y is maximal if and only if y join x is maximal. Understand? And x join y is maximal, this is repeated. So therefore, with these two lemmas, if x is quasi-complement of y, if and only y is quasi-complement of x. That is observation, because x meet y 0 if and only y meet x 0, and x join y is maximal if and only y join x is maximal. So this together implies, so x and y are quasi-complements to each other. Okay. So this is an example. Let x be a non-empty set, fix an arbitrary x naught. Already I told you discrete ideal definition. Okay. Now define x and y is equal to x if x is not equal to x naught, and y if x is equal to x naught. And x meet y is equal to y if x is not equal to x naught, and x naught if x is equal to x naught. Then this is an ideal with x naught as a 0 element, which is called discrete ideal, and clearly x is quasi-complemented. Clearly x is quasi-complemented ideal. So this is an example. Next definition. Let L be an ideal with maximal element M. Then L is said to be uniquely quasi-complemented ideal if every element has unique quasi-complement. Every element has unique quasi-complement. So this is an example of unique quasi-complemented ideal definition example. So clearly, you take a non-empty set and define operation join and meet as follows. Then this clearly an ideal with 0, and here this A is the unique maximal element in L, and also observe that B meets C 0 and B joins C is A. Therefore, B is the quasi-complement of C. So therefore, A is a quasi-complement of 0. Hence, L is a quasi-complemented radial. Okay. Next theorem, let L be an ideal with maximal element and M the maximal element M, and S be the set of all maximal elements in L. That means you collect all maximal elements. For example, in this diagram, you take every element which is different from x naught is a maximal in this example. And also we have a table. So in this table, this AB1 and AB2 are only maximal elements. So in that sense, you collect all maximal elements. You collect all maximal elements. And S dash is equal to S union singleton 0. Then S dash is an ideal under induced operations in L, and which is a quasi-complemented ideal. And you take only maximal elements with 0. So that can be made it into an ideal, which is a quasi-complemented ideal. Okay. In the following, we prove that in a quasi-complemented ideal L, every dense element is maximal, and Y is a quasi-complement of X, then bracket X star is equal to bracket Y. We prove that every quasi-complemented ideal is a star ideal, and observe that the converse need not be true. We derive a necessary and sufficient condition for a star ideal to become a quasi-complemented ideal, and prove that a uniquely quasi-complemented ideal is a Boolean algebra. We establish a necessary and sufficient conditions for an ADL to become a quasi-complemented ADL and derive some equivalent conditions for an ADL to become quasi-complemented ADL. So this is the theorem. If L is quasi-complemented ADL, then every dense element is maximal. Initially, there is an example that dense element need not be maximal, but in quasi-complemented ADL, dense element is a maximal. And L is quasi-complement ADL, then X belongs to L. If Y is a quasi-complement of X, then bracket X star is equal to Y. And every quasi-complemented ADL is a star ADL. If L is a star ADL, then L is quasi-complemented if and only if every dense element is maximal. This is a necessary and sufficient condition for an ADL to become quasi-complemented. Let L be uniquely quasi-complemented ADL, then L is a Boolean algebra. So this is an important theorem. This lecture, every uniquely quasi-complemented ADL is a Boolean algebra. So in the following, we give necessary and sufficient condition for an ADL with maximal element to become quasi-complemented. Let L be an ADL with maximal element M, then L is a quasi-complemented if and only if L is sectionally complemented. Already you know in lattice theory there is a sectionally complemented. Sectionally complemented and relatively complemented. There are two concepts in lattices. Relatively complemented means every interval AB is a sublattice. But sectionally complemented means all intervals of the form bracket 0, a. Those intervals are sublattices, then we call it as sectionally complemented. Here, L is quasi-complemented if and only if L is sectionally complemented. Okay. If L is an ADL with maximal element M, then L is quasi-complemented if and only if L is relatively complemented. L is relatively complemented. Because relatively complemented means all intervals, bracket AB. But sectionally complemented means a particular intervals. So therefore, this become a corollary. Okay. It can be easily seen that a relatively complemented ADL with maximal element is pseudo-complemented. You know pseudo-complemented lattice? Of course, for who teach the lattice theory, they know pseudo-complemented lattices and stone lattices. Some those are such concepts. With maximal element M is pseudo-complemented ADL, where pseudo-complementation star and L is defined by A star is a pseudo-complement of A in the interval 0, A join. Therefore, every quasi-complemented ADL is a pseudo-complemented ADL, but converse need not be true. Here, every quasi-complemented ADL is a pseudo-complemented, but pseudo-complemented ADL need not be quasi-complemented. That is, so this is an example. So now you consider this ADL. In this ADL, this is clearly quasi-complemented, but not, this is pseudo-complemented, but not quasi-complemented, because this is the description. Next, let L be an ADL with maximal element M. Then L is quasi-complemented if and only if PAL means the set of all principal ideals. Already we know that it is a distributed lattice. Principal ideals, all principal ideals is already we know that is a distributed lattice. So this become a Boolean algebra. That is equivalent to say that an ADL to become quasi-complemented ADL. Okay, so these are the set of identities for an ADL to become quasi-complemented. So let L be an ADL with maximal element, then the following are equivalent. L is quasi-complemented, L is sectionally complemented, L is relatively complemented, and PAL is a Boolean algebra. So any one of these implies L is quasi-complemented. Okay. In the following, we observe that every prime ideal, observe that prime ideals and infinite ideals are independent. And we characterize quasi-complemented ADLs in terms of prime ideals. And we prove that if every prime ideal in an ADL is an infinite ideal, because we give an example of these two are independent. Independent means an example in which prime ideal need not be infinite ideal and infinite ideal need not be prime ideal in ADLs. That says that it is independent. Now, if every prime ideal in ADL is an infinite ideal, then every prime ideal is a maximal ideal, and hence we derive a necessary and sufficient condition for an ADL with a maximal element become quasi-complemented ADL. Okay, and prove that if every prime ideal in ADL is an n-flat ideal, then L is quasi-complemented. First, you consider this as an example. Suppose you take a chain 0 ABC1, and this is the 0 less than A less than B less than C less than 1. We know that this is a chain. Clear, this is an ADL because every chain is, in lattice theory, already there is a result. Every chain is a distributive lattice. Every chain is a distributive lattice. But we know that every distributive lattice is an ADL. Every distributive lattice is an ADL. So therefore, this is an ADL with 0. In this ADL, choose principal ideal generated by B is nothing but bracket AB is a prime ideal. But bracket B star is equal to singleton 0 implies bracket B double star is equal to 0 star. Therefore, 0 star means whole of L. So this is equal to L, which is not contained in bracket B. Thus, this is not an n-flat ideal. Because already we have, I have given an example of an n-flat ideal. I is equal to I double star. Then I is said to be an n-flat ideal because here B double star is not equal, is not contained in B. If B double star is equal to B, then bracket B become n-flat ideal. So here, so this fails. Therefore, this is not an n-flat ideal, but this is a prime ideal. So therefore, that is one example. And you take a power set. This is, of course, a trivial example. This you take a power set. We know that this is always an ADL. And put I star, put I is equal to empty set and singleton A. Then I star is equal to this is, and I double star is equal to, again, singleton A comma, empty set comma singleton A, which is equal to I. Therefore, I is equal to I double star, and hence I is an n-flat ideal. But this is not a prime ideal because bracket B intersection bracket C is equal to empty, which belongs to I. What is prime ideal definition? If X meet Y belongs to P, either X belongs to P or Y belongs to P. Here, this intersection, meet means here intersection, this belongs to I, but none of them belongs to I. So therefore, I is not prime. So therefore, these two examples says that prime ideals and n-flat ideals are independent. Okay. Now, we prove this. Let L be an ideal in which every prime ideal is an n-flat ideal, then every prime ideal is a maximal ideal. And if L is an ideal with maximal element, then L is quasi-complemented if and only if every prime ideal in L is a maximal ideal. That is, in general, prime ideal is not a maximal ideal. But prime ideal is a maximal ideal, then this becomes a quasi-complemented. And if L is an ideal with maximal element M, in which every prime ideal is an n-flat ideal, because already we gave an example that these two are independent. Suppose if prime ideal is an n-flat ideal, then also L is a quasi-complemented ideal. Okay. So these are some results regarding quasi-complemented ideals. And of course, lot of work is still going on this concept with my students. So this is actually, this was published, okay, in Southeast Asian Bulletin of Mathematics. This is one of my student, his PhD thesis, okay, on this concept. So these are certain references for this lecture, okay. This coordinates quasi-complement lattice. This is my research director, Professor Chakradhara Garu. I think many of them, you know, Professor Chakradhara Garu. Is a doctoral thesis we are using. And Professor Chakradhara, myself and my student, okay. And of course, so these are some results which are published in Asian European Journal of Mathematics. And you know, Professor U.M. Swami, I think everybody knows, everybody knows Professor U.M. Swami and Chakradhara Garu. Actually, this concept, actually, this is the base, almost distributed lattice in 1981, which was published in Australian Mathematical Society. Is a very big journal, okay. From that, more than 20 PhDs done on this ideal concept. And myself, I again, I defined, I used this concept for semi-lattices. I defined almost semi-lattices. And of course, 3 students already, they got their doctorates on this concept, and still the research is going on. Okay. And Professor U.M. Swami, Chakradhara Garu, and myself. Okay. This is my thesis title, Pseudo Complementation on Almost Distributed Lattice, which was published in Southeast Asian Bulletin of Mathematics. This is published in Springer Verlag. Of course, you teachers already know this Springer Verlag is a world top publishers. And of course, my three members, myself and my teachers. You know, Professor U.M. Swami is a teacher in my MSc, and Professor Chakradhara is my research director, but my PhD doing under both of them. Okay. The stone almost distributed lattices, already stone lattices already is there, but we introduced the stone concept in ADLs. This is also published in Southeast Asian Bulletin of Mathematics. Okay. And dense element concepts also published. And we are using Saz book. I know this book is well known for MSc students. Saz, Introduction to Lattice Theory. Okay. So these are we are using for references. And thank you. Thank you, madam.
Thank you, sir. Thank you so much.
I think most of the MSc students, maybe if anybody after they completed their MSc, who are interesting to do research in lattice theory particularly.
Exactly,
okay?
sir. Exactly.
Particularly in lattice theory,
yes,
you must contact with our department, and particularly, you know, my email and everything, address,
yes,
phone numbers and everything is there.
I will give them. Yes,
yes, sir. Who are interesting in lattice theory, I always encourage the such students.
Okay?
Yes,
sir. Sure, sir. Sure, sir.
Okay. Thank you. And particularly, thank you very much for this great occasion on today's great mathematician, Indian mathematician, Sir Srinivas Ramanujan sir, birthday anniversary. And we are proud as a mathematicians.
Yes, sir.
మనం అంత స్థాయి కాకపోయినా యాజ్ ఎ mathematicians గా
అంటే belong to that family కాబట్టి
we are as a family member. That is the only satisfaction, because we are the family members of mathematics. And in particularly this lattice theory, why it become famous in under Department of Mathematics AU, because this concept many more, I think Professor N.V. Subramaniam, పేరు మీరు వినే ఉంటారు.
Yes sir, విన్నాను sir.
Professor N.V. Subramaniam is actually, we treat him as our grandfather of
yes,
our
sir.
department. Okay.
Yes,
so actually lattice theory is very strong in those days, Professor N.V. Subramaniam.
Yes,
but fortunately I will continue the research on lattice theory because in చెప్పండి మేడం.
స్టార్టింగ్ నేను కూడా లాటిస్ థియరీ మీద స్టార్ట్ చేశాను సార్, నా రీసెర్చ్ వర్క్ కూడా. కానీ ఈ సాచురేషన్ పాయింట్స్ కనిపిస్తున్నాయి ఎక్కడికక్కడ అని చెప్పి నేను మళ్ళీ ఇటు టర్నరీ గామా వైపు వెళ్ళాను సార్.
బట్ దెర్ ఇస్ లాట్ ఆఫ్ వర్క్ స్టిల్ గోయింగ్ ఆన్. చాలా ఉంది దీంట్లో ఇంకా మనం చేసుకోవడానికి. అంటే న్యూ కాన్సెప్ట్స్ ఇప్పుడు మా మాస్టారు ఏడిఎల్ ఇంట్రడ్యూస్ చేశారు. దాని మీద నేను సూడో కాంప్లిమెంటేషన్ నా థీసిస్, తర్వాత ఈ క్వాజీ కాంప్లిమెంటెడ్ నేనేమో ఆల్మోస్ట్ సెమీ లాటిస్, దాని మీద సూడో కాంప్లిమెంట్స్ నేను మళ్ళీ వేరే ట్రాక్ ఫామ్ చేసుకున్నాను. సో కాబట్టి నేను క్వాజీ కాంప్లిమెంటెడ్ తర్వాత నా సెమీ లాటిస్ ఆల్రెడీ ఉంది మనకి లాటిస్ థియరీలో. సో నేనేంటంటే ఆల్మోస్ట్ సెమీ లాటిస్ అని నా కాన్సెప్ట్ ఇంట్రడ్యూస్, దాని మీద ఆల్రెడీ ఒక 4 PhDs ఆల్రెడీ ద అవార్డెడ్.
సార్ ప్రెసెంట్ మాకు ఇక్కడ థర్డ్ సెమిస్టర్ రన్ అవుతుంది కదా సార్, థర్డ్ సెమిస్టర్ కి ఒక పేపర్ లాటిస్ థియరీ సార్, ఇప్పుడు సెకండ్ యూనిట్ లో ఉన్నారు సార్ వాళ్ళు.
అందుకే నేను అంటున్నా MSc పిల్లలకి కొంచెం లాటిస్ థియరీ మీద ఆల్రెడీ అవగాహన ఉంది కాబట్టి ఎవరన్నా రీసెర్చ్ మీద ఇంట్రెస్ట్ ఉండి ప్లస్ పిల్లలకి అంటే రేపు పొద్దున్న ఏదైనా రీసెర్చ్ టెస్ట్ అది రాసి పిల్లలు ఎవరైనా ఉంటే వాళ్ళకి ఏమన్నా మీరు
మీకు రిఫర్ చేస్తాను సార్,
రిఫర్ చేయండి, నేను వాళ్ళకి గైడ్ చేస్తాను. అలాగే మీరు కూడా ఎవరైనా కొలాబరేటివ్ గా రీసెర్చ్ చేద్దామంటే నో ప్రాబ్లం, ఆల్వేస్ వెల్కమ్.
షూర్ సార్, షూర్.
ఓకే మేడం, particularly thank you for Ravati madam for giving this opportunity to deliver a lecture on the great day of great mathematician Professor Srinivas Ramanujan birthday anniversary. Thank you very much.
Thank you sir. Thank you very much sir. for your valuable talk in lattice theory. It is very useful to students for their research work. And it's a great opportunity to our students which are interested in research and their further studies also, sir. And thank you very much, sir, for accepting my invitation and gave us a useful and inspirable talk, sir.
Thank you.
Thank you, sir. Okay, sir.
తర్వాత ఇంటరాక్షన్ ఎవరైనా స్టూడెంట్స్ ఏమైనా మాట్లాడతారా? ఉన్నారా లైన్ లో?
అడుగుతాను సార్,
అడగండి. ఇది స్టూడెంట్స్ భయపడుతున్నారేమో, జనరల్ టాక్ అని చెప్పండి, జస్ట్ జనరల్ డిస్కషన్. ఎందుకంటే పిల్లలకి ఈ మధ్యన మనం చూస్తున్నాం కదా, మీరు యాజ్ ఎ టీచర్స్ మీరు అందరూ చెప్తూ ఉంటారు. బట్ ఇప్పుడు పిల్లలు ఏంటంటే చదువు అంటే ఏంటనే దాని మీద చాలా మందికి చదువు అంటే జస్ట్ థియరమ్ ప్రూఫ్ మార్క్స్ అదే కదా అనుకుంటున్నారు చాలా మంది. థియరమ్ ప్రూఫ్ మార్క్స్ అనేది అది ఒక్కటే కాదు. ఎడ్యుకేషన్ అంటే చాలా ఉంది. పిల్లలకి అది ఎంతవరకు మనం మోటివేట్ చేయగలుగుతున్నాం, వాళ్ళు ఎంతవరకు రిసీవ్ చేసుకుంటున్నారు అనేది చాలా చాలా ఇంపార్టెంట్ మేడం. ఎందుకంటే పర్టికులర్గా పిల్లల్ని నేను అబ్జర్వ్ చేస్తున్నాను కదా, ఇదేంటంటే డే బై డే స్టెప్ బై స్టెప్ అలాగ వాళ్ళ తాలూకా ఇప్పుడు ఇలాంటి గ్రేట్ మ్యాథమెటిషియన్స్ అంత ఎర్లీ ఏజ్లో వాళ్ళు అంత వరల్డ్ వైడ్ అంత టాప్ వాళ్ళకి ఏంటి అంత పేరు రావడానికి వాళ్ళు కారణం ఏంటంటే బికాస్ ఆఫ్ ద డిసిప్లైన్. దట్ ఈస్ వెరీ ఇంపార్టెంట్. ఇప్పుడు ఆ డిసిప్లైన్ అంటే మన ఏదో ఎలా అని కాదు. డిసిప్లిన్ అంటే దాంట్లో చాలా ఫ్యాక్టర్స్ ఉన్నాయి కదా మనకు తెలుసు. ఏంటంటే అప్పుడు ఫస్ట్ మనకి అసలు ఎక్కడ స్టార్ట్ అవ్వాలి, పేరెంట్స్కి మనం ఎలా రెస్పెక్ట్ ఇవ్వాలి, వాళ్ళతో ఎలా మాట్లాడాలి, ఏవి డిస్కస్ చేయాలి, ఏవి చేయకూడదు, ఇలాంటి టాపిక్స్ అన్నీ కూడా వాళ్ళు ఏంటంటే మనం ఫస్ట్ పేరెంట్స్ స్టార్ట్ అయ్యి అక్కడ నుండి హై స్కూల్ స్టేజ్ అనేది చాలా నా ఒపీనియన్, హై స్కూల్ స్టేజ్ అనేది చాలా ఇంపార్టెంట్. అక్కడ నుంచి పిల్లలు మోటివేట్ చేసి మనం పంపించగలిగితే వాళ్ళు గ్యారెంటీగా టర్న్అప్ అవుతారు. అంటే ఎంతసేపు మార్క్స్ అనే దాని మీద వాళ్ళు రుద్దేసి వాళ్ళకి అసలు జీవితానికి ఏంటి కావాలనే దాన్ని టర్న్అప్ చేసేసి పిల్లలు ఇంకా ఇంటర్ డిగ్రీకి వచ్చిన తర్వాత ఇదే కరెక్ట్ ఏమో అనుకుని దాన్ని ట్యూన్ అయిపోతున్నారు పిల్లలు మెయిన్గా. దిస్ ఈస్ వెరీ అన్ఫార్చునేట్. ఎందుకంటే తర్వాత చదివే విధానం, అసలు చదివే విధానం ఏంటి? ఇప్పుడు చాలా మంది చదువుతున్నారు, మనకి రిలేషను ఫంక్షన్ ఇవన్నీ కూడా స్టార్టింగ్ లో చెప్తాం, సెట్ థియరీ నుంచి వస్తాయి ఇవన్నీ. ఎంతమందికి రిలేషన్ అంటే డెఫినేషను లేకపోతే ఫంక్షన్ అంటే డెఫినేషను, దానికి ఏమైనా ఎగ్జాంపుల్స్ వాళ్ళు క్రియేట్ చేసి ఇవ్వగలరా, అది ఎంతవరకు టీచర్స్ గా నేర్పిస్తున్నారు అనేది కూడా ఒక్కసారి చాలా ఇంపార్టెంట్ అది. ఎందుకంటే వాళ్ళు అగైన్ రీసెర్చ్ వరకు వచ్చేసరికి వాళ్ళు చాలా ఇబ్బంది పడిపోతున్నారు. ఒకటి, రెండోది ఏంటంటే అప్పుడు నేర్చుకోవడానికి వాళ్ళకి సర్టెన్ ఈగో ప్రాబ్లమ్స్. ఎందుకంటే వాళ్ళు మేము రీసెర్చ్కి వచ్చేసాము ఇంకా ఎప్పుడో వాళ్ళ అవి నేర్చుకోమంటారేంటి అనేది కొన్ని దేర్ ఆర్ సర్టెన్ ఈగో ప్రాబ్లమ్స్, నో డౌట్. అది బయటికి చెప్పలేరు కానీ అది ఉంటాయి, మనసులో ఉంటాయి వాళ్ళకి. అది మనం ఏంటంటే అడిగేసరికి ఇదేంటి ఇలాగ అడిగేసరికి కోపడుతుంటారు కానీ ఆ నేర్చుకోవడానికి ఇంట్రెస్ట్ చూపించరు మెయిన్గా. అందువల్ల ఏంటంటే ఆ బేసిక్ ఆ నాలెడ్జ్ అనేది మనకి ఏంటంటే పిల్లలకి స్టార్టింగ్ నుంచి మనం ఇవ్వగలగాలి. ప్లస్ వాళ్ళు కొద్దిగా మనం వాళ్ళు చదువుతున్నారు లేదా అనేది మనం కూడా టీచర్స్గా చూడవలసిన రెస్పాన్సిబిలిటీ ఉంది నేను అనుకుంటున్నాను. ఎందుకంటే నేను రీసెర్చ్కి వచ్చిన పిల్లలు అబ్జర్వ్ చేస్తున్నాను కదా చాలా మందిని. వాళ్ళకి ఏంటంటే ఆ ఫండమెంటల్స్ వీక్గా ఉండటం వల్ల వీళ్ళు అనుకుంటున్నారు ఆ ఫండమెంటల్గా చదివేది అనేది జీవితానికి చాలా అవసరం. మనం ఏంటంటే జీవితం వేరు ఇది వేరు అనుకుంటున్నారు. ఈ ఫండమెంటల్సే మనం లైఫ్లో ఎలాగ ఉండాలి అనేది మనకి రూట్ నేర్పించేది కూడా అదే. మనం అనుకుంటున్నాం కదా ప్రాబ్లమ్స్ అండ్ సొల్యూషన్స్. ఇప్పుడు నేచర్ ఎలా డిజైన్ చేస్తుందంటే సిస్టమ్ని ప్రాబ్లమ్స్ పెడుతుంది, సొల్యూషన్స్ పెడుతుంది. రెండు సెట్లు, వాటి మధ్యలో బైజెక్షన్ ఉంటుంది. మనం ఏమనుకుంటున్నాం మ్యాథమెటిక్స్ లో చదువుతున్నాం కానీ రియల్ లైఫ్ కి అప్లై చేయట్లేదు చాలా మంది. చాలా మంది చూస్తున్నాం కదా సూసైడ్ చేసుకుంటారు. అంటే ప్రాబ్లం వచ్చింది దీని పరిష్కారం లేదు అనేది ఇట్స్ అన్ ఇన్నోసెంట్ వే ఆఫ్ థింకింగ్ కదా. బట్ నేచర్ ఆల్వేస్ డిజైన్ ఏ ప్రాబ్లమ్ సెట్ అండ్ ఏ సొల్యూషన్ సెట్, and there is always a bisection. Whenever there is a problem there is a solution and converse also. Okay na? మరి అది అనలైజ్ ఎలా చేయాలంటే చదివేటప్పుడే రావాలి పిల్లలకి ఆ లాజిక్.
అవును సార్, మనకి సామెత కూడా ఉంది, శతకోటి క్వశ్చన్లకి అనంత కోటి ఉపాయాలు ఉంటాయటండి.
అదే కదా ఇప్పుడు మనం మార్కెట్కి వెళ్తాం, షాప్ ఏదో సూపర్ మార్కెట్కి వెళ్ళినప్పుడు అన్ని కొనేం కదా, ఏది మనం అప్రోప్రియేట్ గా ముందు ఇది బాగుంది అని అనుకుంటాం కానీ వచ్చేటప్పుడు అప్రోప్రియేట్ గా ఏది అవసరమో అదే కొంటాం. అంటే అక్కడ అనలైజ్ చేస్తున్నాం థింగ్, ఇది ఎంతవరకు అవసరం, ఈజ్ ఇట్ ఎసెన్షియల్, ఇవన్నీ ఆలోచిస్తాం కదా. మరి రియల్ ప్రాబ్లం వచ్చినప్పుడు ఎందుకు ఆలోచిస్తారు, ఈ ప్రాబ్లం ఎందుకు వచ్చింది, ఇది ఎక్కడ స్టార్ట్ అయింది, దీనికి సొల్యూషన్ ఏంటి. అసలు ఒక్కొక్కసారి సొల్యూషన్స్ అనేవి వెంటనే దొరకవు కొన్ని ప్రాబ్లమ్స్కి. ఇట్ విల్ టేక్ టైం, నో డౌట్. అమ్మా పిల్లలు, ఎంఎస్సి పిల్లలు వింటున్నారా? స్టూడెంట్స్
వాళ్ళ మైకులు అన్మ్యూట్లో పెట్టినట్టున్నారు సార్ స్టూడెంట్స్.
మన వాయిస్ వింటుంది, మన
వాయిస్
వాయిస్
మనది వెళ్తుంది సార్.
చూడండి మేడం, ఒకళ్ళిద్దరైనా వింటున్నారా అట్లీస్ట్ ఫర్ మై సాటిస్ఫాక్షన్?
అందరూ వింటున్నారు సార్, స్టూడెంట్స్ అందరూ
ఓకే.
వింటున్నారు.
ఇప్పుడు
కాకపోతే వాళ్ళ మైకులు మొత్తం అన్మ్యూట్ లో ఉన్నాయి సార్.
ఓకే, నో ప్రాబ్లం. వింటే చాలు, నాకు వింటే మనకి చాలు.
వింటున్నారు.
ఓకేనా? ఇప్పుడు పిల్లలకి ప్రాబ్లమ్ అనలైజింగ్ కెపాసిటీ అనేది ఇట్ కమ్స్ త్రూ ఎడ్యుకేషన్, అంతే కదా. చదువు అంటే థియరం ప్రూఫ్ కాదు కదా. ఒక ప్రాబ్లం ఇచ్చినప్పుడు మ్యాథమెటికల్ ప్రాబ్లం ఉంది, ప్రాబ్లంకి సొల్యూషన్ ఏంటి అనేది ఒక్కొక్కసారి వెంటనే దొరుకుతుంది, లేకపోతే ఇట్ విల్ టేక్ టైం. ఒక్కొక్కసారి 10 సంవత్సరాల తర్వాత దొరకవచ్చు రియల్ లైఫ్ లో ప్రాబ్లం. మనకి అన్నిటికీ కావాలంటే మనకి పేషెన్సీ కావాలి, మెయిన్ ఓపిక అనేది చాలా అవసరం. మనిషికి ఈ మధ్యన ఎలా ఉందంటే స్పీడ్ దాన్ని తగ్గించుకోకపోతే మనమే ప్రాబ్లం క్రియేట్ చేసుకునే వాళ్ళు అవుతాం. నేను ఫీల్ అయ్యేది ఏంటంటే మన ప్రాబ్లమ్స్ కి మోర్ దాన్ 99% మనమే కారణం. ఇది ట్రూ, నేను ట్రూ అని నమ్ముతున్నాను. ఎందుకంటే మన ప్రాబ్లమ్స్ కి మనమే కారణం. మనం కావాలని పేరెంట్స్ మీద, టీచర్స్ మీద, ఫ్రెండ్స్ మీద రుద్దుతాం, కానీ అసలు ఎగ్జాక్ట్ గా మన ప్రాబ్లం కి మనమే కారణం, అందులో డౌట్ ఏం లేదు. కాకపోతే ఎస్కేప్ అవడానికి, తప్పించుకోవడానికి వాళ్ళు అమ్మ నాకు టైం మీద బుక్ కొనివ్వలేదు, లేకపోతే అది కొనివ్వలేదు, వాళ్ళ మీద రుద్దుతాం అంతే తప్ప రియల్ గా మన ప్రాబ్లమ్స్ అందులో డౌట్ ఏం లేదు. కాబట్టి పిల్లలు ఏంటంటే చెప్పండి.
హై స్కూల్ లెవెల్లోనే కొంచెం పర్సనాలిటీ డెవలప్మెంట్ ప్రోగ్రామ్స్ అలాంటివి కండక్ట్ చేయాలి సార్ పిల్లలకి.
చెయ్యాలి. ప్లస్ టీచర్స్, మనం హై స్కూల్ నుంచి చదువుకొని వచ్చాం, టీచర్స్ పాఠంతో పాటుగా వాళ్ళ ఎక్స్పీరియన్సెస్ అసలు ఎలా ఉండాలని చెప్పేవారు. కొంతమంది, అందరూ కాదు కానీ సమ్ టీచర్స్ కంపల్సరీగా డిస్కస్ చేసేవారు.
చెప్తాము, చెప్పినప్పుడు వాళ్ళు బోర్ ఫీల్ అవుతారు.
లేదు మేడం, అది బోర్ ఫీల్ అయ్యే వాళ్ళు తక్కువ పర్సెంటేజ్ ఉంటారు. అందరూ అలాగా అంటారని మనం చెప్పలేం, కానీ వాళ్ళు వినకపోయినా మనం చెప్పాలి. ఎందుకంటే ఈ రిసీవింగ్ మోడ్ అనేది ఇట్ డిపెండ్స్ ఆన్ ది టైం. ఈ వేళ ఒక 10% పీపుల్ కి మంచి ఇంట్రెస్టింగ్ ఉంది, మిగతా వాళ్ళు బోర్ ఫీల్ అయ్యారు. ఈ 10% అబ్జర్వ్ చేసుకుంటారు, మిగతా వాళ్ళకి అబ్జర్వ్ అవ్వదు. మళ్ళీ మనం రిపీటెడ్ సేమ్ థింగ్ రేపు రిపీట్ చేస్తాం అనుకోండి, మిగతా పర్సెంటేజ్ కొంతమంది అబ్జర్వ్ చేసుకుంటారు. మనం అందుకే ఒక్కొక్క కాన్సెప్ట్ రిపీటెడ్ గా చెప్తూ ఉంటాం టీచర్స్ గా, చెప్పాలి కూడా. దట్ ఈస్ ఎసెన్షియల్ నేను అనుకుంటున్నాను. ఎందుకంటే మనం ఒక్కొక్క మంచి కాన్సెప్ట్ ఒకసారి చెప్పి వదిలేకూడదు. ఇట్ రిపీట్స్ అట్లీస్ట్ 3 or 4 times రిపీట్ చేసాం అనుకోండి. ఆ రిసీవింగ్ మోడ్ అనేది డిపెండ్స్ ఆన్ ది స్టూడెంట్ యాటిట్యూడ్, అంతే కదా. ఈవేళ ఇప్పుడు ఒక స్టూడెంట్ ఈవేళ చిరాకు ఉన్నంత మాత్రం రేపు చిరాకు ఉండాలని లేదు కదా. రేపు సపోజ్ ఇంట్రెస్టింగ్ ఉండొచ్చు, అప్పుడు మనం చెప్పి తన బ్రెయిన్ లోకి వెళ్ళొచ్చు. అందువల్ల ఏంటంటే రిపిటేషన్ అనేది చాలా అవసరం. మంచి మనం ఏదైనా జనరల్ థింగ్స్ మనం డిస్కస్ చేసినప్పుడు, సో అది కంపల్సరీ అని అనిపించింది నాకు. ఓకేనా? సో ప్లస్ ఇదొకటి. ఇంకా రెండోది, ఎంఎస్సి పిల్లలకి ఈ శ్రీనివాస్ రామానుజన్ గురించి మనకి బోల్డ్ అంత మెటీరియల్ ఉంది. ఇప్పుడు ఆయన కదా, మన అబ్దుల్ కలాం గారు, ఇలాంటి గొప్ప వీళ్ళంతా కూడా ఏ స్థాయి నుంచి ఏ స్థాయికి ఎదిగారనే దానికి మనకి ఇప్పుడు ఇంటర్నెట్ లో మనకి ఆ యూట్యూబ్ లో కొడితే వాళ్ళ బయోగ్రఫీ అన్ని ఉన్నాయి. పిల్లలకి నా బెస్ట్ సజెషన్ ఏంటంటే, మనం రోజులో చాలా టైం అన్నెసరీగా వేస్ట్ చేస్తాం. నేను అనేది ఏంటంటే, యూ టేక్ వన్ బెస్ట్ మ్యాథమెటిషియన్, ఒక్క బయోగ్రఫీ, ఒక మ్యాథమెటిక్స్ సంబంధించి ఒక్కొక్క బయోగ్రఫీ ఒక్కొక్క రోజు చదువుకోండి ఖాళీ టైంలో. అంటే మీ ప్రిపరేషన్ అయిపోయిన తర్వాత నాకు ఈ టైం ఖాళీ ఉంది అనుకున్నప్పుడు, ఇప్పుడు వాళ్ళ హిస్టరీలు చదివితే వాళ్ళు ఎంత కష్టపడ్డారు, వాళ్ళు ఎలా కష్టపడ్డారు, ఎలా ఆలోచించారు అన్నీ కూడా మనకి కొంత అవగాహన వస్తుంది. మనం రోజులో చాలా టైం వేస్ట్ చేస్తుంటాం. మీరు చదవాలి, కానీ ఎంతో గ్రేట్ మ్యాథమెటిషియన్స్ వాళ్ళకి బయోగ్రఫీలు అన్ని అదృష్టం కొద్ది వేళ అవైలబిలిటీ ఉంది ఇప్పుడు. ఎందుకంటే ఇంటర్నెట్, ఒకప్పుడు మన లైబ్రరీకి వెళ్తే దొరికేవి, కానీ ఇప్పుడు ఇంటర్నెట్ లో అవైలబిలిటీ ఉంది. పిల్లలు ఏంటి మేడం,
అన్ని చేతిలోనే
చేతిలో ఉన్నాయి. మీకు సెల్ ఫోన్ ఉంటే అన్ని వచ్చేస్తున్నాయి, ప్రపంచం అంతా మీ ముందు ఉంది. కాబట్టి బెస్ట్ ఆప్షన్ ఏంటంటే మనల్ని మోటివేట్ చేసుకోవడానికి, టర్న్ అప్ చేసుకోవడానికి, మన యాటిట్యూడ్ మార్చుకోవడానికి చాలా గ్రేట్ పీపుల్ ఇండియాలో వరల్డ్లో చాలా మంది ఉన్నారు. మీకు నచ్చిన ఒక మంచి మ్యాథమెటిషియన్ తీసుకోండి, వాళ్ళ బయోగ్రఫీ చదవండి, చదువుకొని మీ ఫ్రెండ్స్తో షేర్ చేయండి. మీరు చదివింది ఎప్పుడు కూడా షేర్ చేసుకోవడం వల్ల దాని మీద మనకి చాలా ఏంటంటే దాని మీద కమాండింగ్, దాని మీద ఇంట్రెస్ట్ అన్ని పెరుగుతాయి. మీరు ఒక కాన్సెప్ట్ నేర్చుకున్నప్పుడు మన ఎదుటి మనిషి చెప్పడం వల్ల దాని మీద ఇంట్రెస్ట్ పెరుగుతుంది. అందువల్ల చదవటం, ఏదో బెస్ట్ ఫ్రెండ్స్ తో షేర్ చేసుకోవడం, ఆయన ఎంత కష్టపడ్డారని మన 15 సార్లు అనుకున్నప్పుడు
వాళ్ళ ఇండివిడ్యువల్ పర్సనాలిటీ డెవలప్మెంట్ పెరుగుతుంది సార్.
పెరుగుతుంది, డెఫినెట్ గా పెరుగుతుంది. లేకపోతే మన మైండ్ ఇలా వదిలితే అది ఎటో పారిపోతూ ఉంటుంది. అందులో పర్టికులర్గా బిఎస్సి లెవెల్, ఎంఎస్సి లెవెల్లో ఈ మైండ్ ఎలా వదిలేమంటే ఆ స్పేస్లో తిరుగుతూ ఉంటుంది. కాబట్టి దాన్ని కంట్రోల్ చేయాలంటే మనం ముందు ఇది పెట్టుకోవాలి. ఇలాంటి పెట్టుకున్నప్పుడు డెఫినెట్గా ఇప్పుడు ఒక్కొక్క మనిషి లైఫ్ ఇంకొక మనిషి జీవితాలు కూడా మార్చే ఛాన్సెస్ ఉన్నాయి. అంతే కదా, చాలా మంది మోటివేట్ అవుతూ ఉంటారు.
ఇన్స్పైర్ అవుతారు.
ఆ ఇన్స్పిరేషన్ అనేది చాలా మందికి అవసరం. కొంతమంది తెలియక అయిపోయిన వాళ్ళు చాలా మంది ఉన్నారు. మనం క్లాసులో చెప్తూ ఉంటాం, మీరు గేట్ రాయాలి, సిఎస్ఆర్ నెట్ రాయాలి, లేకపోతే సివిల్స్కి వెళ్ళాలని చెప్తూ ఉంటాం. ఎలా వెళ్ళాలి, ఎలా ప్రిపేర్ అవ్వాలి, దానికి ఏంటి కావాలని మనం చెప్తూ ఉంటాం. పదే చెప్పినప్పుడు ఫస్ట్ సారి కొంత వాళ్ళు అబ్జర్వ్ చేసుకోలేకపోయినా అలా చెప్తూ ఉన్నప్పుడు ఏదో ఒక రోజులో క్లాస్లో ఒక్కరిద్దరు అబ్జర్వ్ చేసుకున్నా చాలు మనకి. అంతే కదా, ఇప్పుడు ఉంటుంది, అది గ్యారంటీ ఉంటుందని నేను నమ్ముతాను. అది ఎందుకంటే నాకు అలాంటి ఎగ్జాంపుల్స్ ఉన్నాయి చాలా. ఎందుకంటే వాళ్ళు సెలెక్ట్ అయ్యి మళ్ళీ నా దగ్గరికి వచ్చి, సార్ నేను మీరు చెప్పడం వల్ల నేను ఇది సెలెక్ట్ అయ్యానండి, లేకపోతే నాకు ఇక్కడ పిహెచ్డి సీట్ వచ్చిందండి, ఇలాంటి పిల్లలు చాలా మంది
ఉంటారు సార్.
ఉంటారు, గ్యారంటీగా ఉంటారు.
ఉంటారు సార్. 30 to 40% స్టూడెంట్స్ అచీవ్ చేస్తారు, మళ్ళీ వచ్చి చెప్తూ ఉంటారు.
మీకు లైవ్ ఎగ్జాంపుల్ ఇస్తాను, ఏమన్నా మీకు లైవ్ ఎగ్జాంపుల్. మీ డిపార్ట్మెంట్ లో సుజాత ఉంది, అడగండి. సుజాత ఈజ్ అన్ ఎగ్జాంపుల్. అర్థమైందా? అమ్మాయి ఎంఎస్సి చదివేటప్పుడు సార్ పిహెచ్డి నేను చేయాలనుకుంటున్నాను, నా దగ్గరికి వచ్చి చాలా సార్లు అడిగింది, పిహెచ్డి చేయాలంటే ఏం చేయాలండి, ఎలాగా, దానికి ఏం ప్రిపేర్ అవ్వాలని చాలా సార్లు నన్ను అడిగింది తను. అర్థమైందా? దట్ ఈస్ వన్ లైవ్ ఎగ్జాంపుల్. మీ డిపార్ట్మెంట్ లో ఉన్నారు తను. ఓకేనా?
గురువులు అంటే అట్లాగే వాళ్ళ శిష్యుల గురించి చెప్పుకుంటారు సార్.
అప్పుడు అలా కాదు, నేను ఎందుకు ప్రెస్టేజ్ గా చెప్పుకుంటున్నాను, నా స్టూడెంట్ అమ్మ అనుకున్న గోల్ సాధించింది, అవునా కదా? సో నేను అనేది ఇదే. ఇప్పుడు మీకు ఎంఎస్సి పిల్లలు వింటున్నారు, నేను చెప్పిన టాపిక్ వింటున్నారని అనుకుంటున్నాను. అమ్మ ఎంఎస్సి స్టూడెంట్ పిల్లలు, మీరందరూ మంచి అంబిషన్ పెట్టుకోవాలి. మీ మాస్టర్లు ఏం చెప్తే అది చక్కగా. ఇప్పుడు ఒక్కొక్క మనిషికి ఒక్కొక్క ఫీల్డ్ ఇంట్రెస్ట్ ఉంటుంది, అందరికీ అన్ని ఫీల్డ్లో ఉండాలని లేదు. ఇప్పుడు ఒక్కొక్కరు బ్యాంకింగ్ సైడ్, ఒక్కొక్కరికేమో సర్వీస్ కమిషన్, ఒక్కొక్కరికేమో టీచింగ్ లైన్, కొంతమందికి ఇంకా హైయర్ డిగ్రీ చేయాలి, పిహెచ్డి చేయాలని అంబిషన్స్ ఉంటాయి. దానికి తగ్గట్టుగా మీరు ఎంఎస్సిలో ఉండగానే టార్గెట్ ఫిక్స్ చేసుకొని దానికి అప్రోచింగ్ ఇక్కడి నుంచే మొదలెట్టాలి. ఎంఎస్ అయిన తర్వాత నేను డెసిషన్ తీసుకుంటానంటే మీకు సలహాలు ఇచ్చే వాళ్ళు ఉండరు. కాబట్టి ఎంఎస్సి పిల్లలకి ఇచ్చే సజెషన్ ఏంటంటే, మీరు ఏదన్నా టార్గెట్ అనేది ఆ మాస్టర్లతో ఇంటరాక్షన్ ఉన్నంతసేపే మీరు టక్మని టార్గెట్ ఫిక్స్ చేసుకొని మీ ప్రిపరేషన్ మొదలెట్టేసుకోవాలి. మొదలెట్టుకుంటే డెఫినెట్గా ఆఫ్టర్ ఎంఎస్సి మీరు విదిన్ 1 or 2 years మీరు మంచి అనుకున్న గోల్ సక్సెస్ అయిపోతారు. ఈ రామానుజన్ బర్త్డే సందర్భంగా పర్టికులర్గా నేను ఎంఎస్సి స్టూడెంట్స్కి ఇది ఇచ్చే నేను సలహా, ఓకేనా? సో అందరూ శ్రీనివాస్ రామానుజన్ అయిపోకర్లేదు, కానీ ఆయన ఇన్స్పిరేషన్గా తీసుకొని అంత స్థాయికి ఎదగాలని ప్రయత్నించడంలో తప్పులేదు. అయినా అవ్వచ్చు, ఇంకా అంతకంటే గొప్ప కూడా అవ్వచ్చు. ఏది కూడా ఇక్కడితో లిమిట్ అనేది ఏం లేదు ఈ యూనివర్స్లో. ఏదన్నా ఎంతవరకైనా ఎక్స్టెండబుల్ అవుతుంది, ఓకేనా? సో కాబట్టి బాగా చదువుకోండి. డౌట్ క్లారిఫికేషన్ అనేది చాలా ఇంపార్టెంట్. పాఠాలు చెప్పినప్పుడు మాస్టర్ డౌట్ వచ్చిన వెంటనే క్లారిఫై చేసుకోండి. ఇక్కడ మనం ఒక్కటేంటంటే, నేను అబ్జర్వేషన్ ఏంటంటే, డౌట్ అడిగేటప్పుడు డౌట్ వస్తుంది, అడగాలనిపిస్తుంది, మళ్ళీ ఆపేసుకుంటాం. ఎందుకంటే పక్క వాళ్ళు కామెంట్ చేస్తారని, వాళ్ళు కామెంట్ చేస్తారని అడగాలనుకుంటాం, అడగము, అలా మర్చిపోతాం. మరి ఆ డౌట్ అలాగే ఉండిపోయింది. డౌట్ క్లారిఫికేషన్ చాలా ఇంపార్టెంట్. ఇప్పుడు ఒక డెఫినేషన్ నీకు అర్థమైందా లేదా అనేది టెక్స్ట్ బుక్లో చదివి డెఫినేషన్ చదువుతారు, మీరు అర్థమవుతుంది. ఇచ్చిన ఎగ్జాంపుల్ చదువుతారు, అర్థమవుతుంది. అంటే నీకు ఓన్లీ 50% నువ్వు అందులో సక్సెస్ అయినట్టు. రిమైనింగ్ 50% ఏంటంటే, యూ క్రియేట్ యువర్ ఓన్ ఎగ్జాంపుల్. యూ క్రియేట్ యువర్ ఓన్ ఎగ్జాంపుల్ ఫర్ ద డెఫినేషన్. ఆ డెఫినేషన్ నీ ఓన్గా ఎగ్జాంపుల్ క్రియేట్ చేసినప్పుడే నీకు అది 100% అర్థమైనట్టు. కాబట్టి మీరు అనుకుంటారు, చదివేసాం అనుకుంటారు. చదివేయడం అంటే ఇచ్చింది అర్థం చేసుకోవడం కాదు. యూ క్యాన్ క్రియేట్ యువర్ ఓన్ ఎగ్జాంపుల్. అంతవరకు నీకు ఆ గ్యాప్ ఉంది ఇంకా. అందువల్ల ఏంటంటే, ఏదైనా ఒక డెఫినేషన్ ఇచ్చినప్పుడు అర్థం చేసుకోవాలి, ఆ ఎగ్జాంపుల్ అర్థం చేసుకోవాలి, దెన్ యూ క్రియేట్ యువర్ ఓన్ ఎగ్జాంపుల్. అప్పుడు నీకు దాని మీద 100% కమాండింగ్ వచ్చినట్టు. సో అది చదివే విధానం. అలా చదువుకోండి. డౌట్ వచ్చినప్పుడు మీ టీచర్స్ని వెంటనే అడగడం, క్లారిఫై చేసుకోవడం, ప్లస్ అర్థమైపోతుంటే మనకి రిమైనింగ్ అన్ని కూడా ఈజీ అయిపోతుంటాయి, ఓకేనా? సో పర్టికులర్గా ఈ బిఎస్సి ఎంఎస్సి స్టూడెంట్స్కి ఈ అకేషన్ శ్రీనివాస్ రామానుజన్ గారి బర్త్డే సందర్భంగా ఐ విష్ యూ ఆల్ ది బెస్ట్. అండ్ మీరందరూ కూడా గొప్ప గొప్ప మ్యాథమెటిషియన్స్గా తయారవ్వాలని మనస్ఫూర్తిగా కోరుకుంటూ, నాకు ఈ అవకాశాన్ని ఇచ్చిన పర్టికులర్గా డిపార్ట్మెంట్ ఆఫ్ మ్యాథమెటిక్స్, అధిక నాని యూనివర్సిటీ and particularly Ravati madam. Okay, thank you very much.
Thank you, sir. Thank you so much, sir.
Thank you, Amma. Madam?
Sir.
ఇంకేంటి నెక్స్ట్ అకేషన్? ఓకేనా?
ఓకే సార్. ఓకే సార్, అయితే నెక్స్ట్ ఐ ఇన్వైట్ మిస్టర్ కేవి. నెక్స్ట్ సార్ ఒక చార్ట్ ఉంది సార్ ఇక్కడ.
నేను ఇది స్క్రీన్ షేర్ ఆపేనా?
లేదు సార్, క్వశ్చన్స్ ఏమీ లేవు సార్ ఇక్కడ.
ఓకే, చూడండి ఏమైనా ఉంటే.
స్టూడెంట్స్ ప్లీజ్ పోస్ట్ ఎనీ క్వైరీస్. అమ్మా, ఎవరైనా మాట్లాడాలనుకుంటే హ్యాండ్ రైజ్ చేయండి అమ్మా.
ఓకే స్టూడెంట్స్, మీకు ఏమైనా లాటిస్ థియరీ, నేను లెక్చర్ సంబంధించి లేదా జనరల్ లాటిస్ థియరీ వాట్ ఎవర్, డిజిఎంఎస్ లాటిస్ థియరీ సంబంధించి ఏమన్నా మీకు ఏమైనా డౌట్స్ ఉంటే అడగండి.
ఇంటరాక్షన్ విత్ నానాజీ సార్ అమ్మా, మళ్ళీ అవకాశం రాదు, మీరు వినియోగించుకోండి. హ్యాండ్స్ రైజ్ చేయండి అన్న. ప్లీజ్ రైజ్ యువర్ హ్యాండ్స్.
మేడం, స్టూడెంట్స్ ఎక్కడ ఉన్నారా? క్లాస్లో ఉన్నారా?
ఉన్నారు సార్, వెబినార్ లో ఉన్నారు సార్.
వెబినార్ లో ఉన్నారు కాదు, ఇక్కడ క్లాస్ రూమ్ లో ఏమైనా ఉన్నారా?
లేరు సార్, లేరు. ప్రెసెంట్ ఆఫ్లైన్ లో ఎవరు లేరు సార్, అందరూ ఆన్లైన్.
ఓకే ఓకే ఓకే
Anybody there? Yes, sir. Raise చేయట్లేదు సార్.
Okay, fine.
Okay, sir. Thank you, sir.
Thank you very much for this opportunity for me. Okay.
Yes.
Madam, నేను లీవ్ అవ్వచ్చా?
Yes, sir. Vote of thanks. Now I invite Mr. KVM Varkumar, sir, one of our colleague, for vote of thanks.
Thank you, madam. Thank you, madam. Good afternoon, all panel members and participants. I am KVM Varkumar, Assistant Professor, Department of Mathematics. I am privileged to have the opportunity to thank the people. Initially, I would like to thank our Honorable Vice Chancellor, Dr. Mokka Jagannath Rao sir, for encouraging and give moral support to organize this webinar and for valuable inaugural speaking. Later, I thank the Registrar, Dr. Kanna Rao sir, for granting permission to conduct this webinar. And thanks to the members, Dr. K. Ramesh sir, Dr. Ashok sir, and Dr. B. Nagan Mohan sir. And now I thank to Dr. K. Ramesh, Principal, UCSE, for supporting us from the beginning of this event. And I thank to all the principals of the university colleges. Now I thank to Professor K. Keshav Reddy sir from JNTU Anantapuram for delivering valuable talk on differential geometry for machine learning. And I thank to Dr. G. Nanaji Rao sir from Andhra University for delivering useful talk on quasi-complementary almost distributed lattice. And now I sincere thanks to Dr. K. Ravati, convener of this webinar, for initiating this national webinar and coordinating us to make this a successful webinar. And I thank to all the co-conveners of this webinars, Mr. T. Srinivas Rao sir, Dr. V. Mallipriya madam, Varkumar sir, J. Ashok sir, J. Alakshmi madam, and Dr. Sujata madam, for your valuable support in making this successful webinar. I thank to Webmaster and his team for technical support to conduct this webinar fruitfully. Last but not least, my thanks to all the dignitaries and all the participants in making this webinar a success and productive. Once again, heartfelt thanks to all the experts, panel members and participants in making this webinar successful from our department. Thanks to all.
Thank you, sir. Thank you, Varkumar sir. The Nanaji sir, in that live example అన్నారు కదండి, వీళ్ళు కూడా లైవ్ ఎగ్జాంపుల్స్ సార్, వర్కుమార్ సార్ కూడా.
అలా కదా, ఆయన స్టూడెంట్ లో ఉంది.
అవును సార్, అదే చెప్తున్నా, వీళ్ళు కూడా మీ లైవ్ ఎగ్జాంపుల్స్ సార్.
అవునా? అదే తను నేను క్లాస్ లో ఎక్కడ చూసాను తన్ని. అదే 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 ఇప్పుడు మాకు ఇక్కడే చేశాడు అబ్బాయి ఎంఎస్సి కదా.
అప్లైడ్ మ్యాథమెటిక్స్ సార్.
ఎస్ సార్, అప్లైడ్ మ్యాథమెటిక్స్ మొన్న పిహెచ్డి కూడా వచ్చాను సార్. నేనే
కాదమ్మా, మీరు ఎంఎస్సి ఎక్కడ చేశారు? ఏయులోనే కదా?
ఏయుఎస్ సార్, అశోక్ సార్ అండ్ గీతా మేడం ఆల్సో సార్.
అవునా? ఓకే ఓకే, మా శిష్యులు ఉన్నారనమాట అయితే.
అవును సార్, మీ లైవ్ ఎగ్జాంపుల్స్ సార్.
లైవ్ ఎగ్జాంపుల్స్. మీరు ఎవరన్నా సరే చెప్పాను కదా, ఇక్కడ సీట్ వచ్చి జాయిన్ అయితే ఓకే, ఆల్వేస్ మీకు అందరికి ఎప్పుడు అది ఉంటుంది యాజ్ స్టూడెంట్స్. ఓకేనా? రైట్.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ సో మచ్ సార్.
ఉంటాను మేడం. ఓకే, మాది ప్రోగ్రామ్ ఉంది 3 o'clock కి.
షూర్ సార్. ఓకే సార్.
రైట్, థ్యాంక్ యూ.
ఓకే, లీవ్ మీటింగ్ చేసేస్తున్నాను.
Okay, students, you may leave now.
వెళ్ళిపోతున్నారు పిల్లలందరూ, వెళ్ళిపోతున్నారు.